all. Bismillahirrahmanirrahim. I welcome you today on the workshop on integrated technology in engineering. And welcome to those people who are online. I think there are about 25 of us, and people who are here physically, and some more people we are expecting. And let them come and we join together and we see what is the situation regarding integration of technology into engineering, what can we do and how to go about it. To start with, let me request Abid Saab to come and recite a word from the Holy Quran.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. صدق الله العظيم.
Can we put the slides on? There are three sets, and set number 1. These slides should be. ये तो यौमे तकबीर है. I have it on my USB. So on. Okay, thank you, Abid Saab. We have here Professor Raza Ali, who is the Dean of Mechatronics Department at University of Engineering and Technology. And we'll have time to listen to him as well. And another group is coming, Mr. Fahad and Chinese lady Gai Yun Mai. And they are a group, they will be talking to you what Chinese are offering in this respect. So we divide today's program in parts. Let me show you some slides. It's set one, and we will talk about how this fourth generation of industrial revolution, they call it. Fourth generation industrial revolution was taken up in China. China is a big example how they assembled their population together, and they used the power of technology to assemble people together. And so we'll first go through these slides, then we'll request Professor Raza Ali, Dean of Mechatronics Department of the University of Engineering and Technology, who will be talking to us, and he let us know what effort is being done in the Mechatronics Department at UET. Then we have another set of slides I'll show you. Then we will talk about the insertion of these technology devices and equipment into infrastructural development. And we will have these Chinese group here will join us, and they will describe us what China is offering with respect to use of this digital technology into our engineering. And then at the end, I have a third set of slides that is regarding entrepreneurship development. How our engineers, I think this is not corrected. नहीं फर्स्ट भी रखिए Basically, China has taken an initiative, and they have formed an international coalition. International coalition on fourth generation of industrial revolution. And in this international coalition, the Institution of Engineers Pakistan has been taken as a founder member. So in this coalition, this is a kind of a technology exchange program. And we are a recipient in this respect, and China will be giving us help in the way of technology transfer and gearing ourselves up. बता दें फौज साहब है वो नीचे ऑप्टिका तक पहुंचे तो उनको बताना है ऊपर आ जाए राइट now we hope to work together. With this is really we are having an MOU with the Chinese Mechanical Engineering Society, and they will be providing us inputs, technology, devices, systems, how that can be inserted, especially in our small towns and small and medium sized enterprises. So let me go through and let you know, how China has taken this fourth industrial revolution. Fourth industrial revolution. First industrial revolution, as you know, took place in Europe, and second industrial revolution was there. As far as Pakistan is concerned, all these industrial revolutions have been mixed up. Nobody knows what took place at one stage or the other. Now, suddenly, we are in the fourth stage. And the fourth stage, we'll exactly come to know, we'll go through these slides and we'll see what does it really mean. And China has taken advantage of this digital technology, because digital technology has a power of connectivity. It connects you to large populations. Distances have been removed, and you can do the transactions. You can do direct banking transfers, all remote areas today, and you can buy and sell. There are buying and selling houses, and you can transfer technologies. You can do such wonderful things today that Pakistan needs. And we'll just go through what took place really in China. China took advantage of this. They had cheap labor. That is the comparative advantage. Because today, if you see all over the world, Chinese products are the cheapest. So they have this comparative advantage that they have utilized the cheap labor, and they have mobilized the small towns and the villages. And they have moved technologies, given technologies to small towns and villages. And 1.2 billion of its population, you can imagine that they are on production and on job. Unfortunately, in Pakistan, we have not really done so. We have not done so. We have not mobilized our large population. 60–70% of our population, I think we have abandoned them, maybe you can call it, or forgotten. So this is the right time, and now the instruments are with us. Now we have the capability, we have the power to approach, to outreach them. This was not with us before. So today is a different situation. We can outreach small, medium towns, villages, everywhere, and spread technology and utilize this labor that they have. So what we need, how to do, how to go about it. That is the aim of this session, this program today. What we see in China, that they reduced the primary sector, large production centers were given less priority, and small sectors were given more priority. That was the change that took place. and they concentrated on villages and small towns. So this is kind of a fourth generation revolution which China undertook, and the state-owned enterprises were really geared towards utilizing the produce of these small enterprises in villages and towns. The villages and the towns, there's small production houses on a very large scale they were energized, and the production is spread out. So this was the comparative advantage that China got into. And as you see, this is a comparison of the secretarial composition, and as you see, red line is the primary industry in China. It is going down, and green line is a secondary industry, which is almost level off, and blue line is the tertiary or small scale industry. Now, as you see, the small scale industry has been rising up. So this is a shift China has undertaken in the last maybe 20 years or so, and because of this shift, they have taken a great commercial advantage of it. But they have been able to reduce the price of the goods, and they have been able to sell the goods all over the world. And as you see here as well, there is you see these bar diagrams. This green color is the business on computers and office equipment. As you see, from 4.3, it has risen to 24.7. So about 6 times increase. 6 times increase in computers and in office equipment. So this, as you see, the trend has been there to maximize the interconnectivity, maximize the use of digital devices, media, and because of this shift, they have been able to assemble people together and spread production into small towns and small units. Now, this red blocks are pharmaceutical. So pharmaceutical also has you see the figure increasing from 7.2 to 24, and electronic and telecommunication equipment. So you see the trend in China in last since last 20 years or so. And this is the map, 2 maps you see, one on the left, one on the right, and you see because of this opportunity that China offered to its population, there has been so come on the front, please. Rajasthan. We have our Chinese team. This is Fawad Saab hai, and this is Mai. How did Mai? Gao Yun Mai. Okay, and this is our friend Chow. As you see on the slide, you see China. We are talking about China. How China utilized the power of technology, internet, and the power of this mobile. It connects you with populations, remote populations, to villages, to towns, to cities. It enables you to do transactions, banking transactions, You can send money anywhere today. There is a power. This is an Aladdin's lamp in your hand. Aladdin's lamp. Unfortunately, we are not utilizing this instrument to that extent, especially the engineers. Mr. Chow, you are here in Institution of Engineers, Pakistan, and we are an engineering body, and we have taken up this task of technology transfer to the maximum extent so that engineers can gear themselves up, train themselves, and be an instrument of change, a change in our industry, a change in our industry from conventional and manual kind of production to automated and connected production. So connectivity and automation. This is the target. So I was just talking about how China became a superpower in economic field, at least. So how China utilized its population of 1.2 billion, mobilized, and they are able to produce goods and services that are cheapest in the world. So the world has to utilize them. So that is a comparative advantage. This is the bar chart, as you see. That you see the emphasis being shifted towards communication equipment, computers, and shift from conventional production, conventional trade to automation, to computers, to internet and connectivity, of course. So I'll spend a few minutes on these slides with you, and then I will request Professor Ravali with us. From mechatronic department, is Dean of Mechatronic Department of the University of Engineering and Technology. And they are doing a lot. They are doing a lot on prototyping and making devices which can be made, which can be commercialized and made available to. We are really targeting small to medium industries in Pakistan. So I will be requesting him, then we will be requesting Mr. Saad and his Chinese colleagues. So we will be having a session together, a kind of a mutual sharing of knowledge, and really target orienting ourselves so that we can see which direction we are going to move, how to train our engineers, what to do. So let me finish this up. As a result of utilizing this comparative advantage, as you see, the household income in China has risen 700%. Household income in China has risen from 1978 to 2008. As you see the red line, this is a rise which has been enabled, rise in the average income because of production, small places production, small village town production, which has been possible because of this technology today. Now, what does really mean technology? When we talk of technology, what kind of technology is it? It's robotics and Internet of Things, IoT that is called, 3D printing, and genetic engineering, with quantum computing and other technologies, artificial intelligence. On this figure, as you see, it's just very simply describes what stages, what generation by generation industrial revolution has gone through. The first industrial revolution, as you see bottom left, is the generation of power and generation of resources. And the second industrial revolution really was around mass scale production. And the third generation was computer and automation. And the fourth generation is this cyber physical system. The system of integrating human beings with machines and with connectivity. Three areas together. We need to make use of it. Today, as you see, even a donkey cart driver has a mobile with him. If a donkey cart driver has can use this mobile, he can get orders. People can approach him, they can call him, and he can move in a very efficient way. Today's world, even technology helps even a donkey cart driver. Two pictures that you see. This on the left is manual kind of work, the manual welding, and on the right you see intelligent welding. Intelligent welding with robots. So this is the shift from one set of way of working to another set of way of working. So this is the change that we are trying to achieve. And as you see, most of our small to medium production centers, we are still sticking to manual ways of working. And we need to change them from manual means to robotic to intelligent means. This is the change we are trying to achieve. And engineers have to bring that change. And to bring that change, we have to equip our engineers, train them, and make them on a certified professional level, so that when they go around in the industry, industry can take them, make use of them. So there has to be a kind of a confidence building. Confidence building when the certified engineering professional walks into a small industry knows that he is the man who can come and help us. This is really a diagram showing how the utilization of skill change has occurred, shifting from manual conventional ways to technologically equipped ways. So this is a shift of manpower or human resource, you could say. Now, there are toolkits. People have already made a systematic approach of how to get about it, how to introduce technology into our small to medium industries, or rather even micro industries. there are toolkits. So I can go through them. You can see what toolkits are available, and it's a matter of setting up a guideline to these small to medium industries. They have to invest. It is a number 1 to number 9, and you see step-by-step approaches there. How to build a perfect smart factory. You have to go through all these 9 steps. Invest in IT and IoT. Invest. The small to medium industry has to be convinced that they have to invest. They have to invest in the IT and IoT. And then they have to develop wireless connections and use the collaborative technologies. They have to have IT and OT. You know what IT and OT are. And they need to train and introduce new required skills. Invest in data management. And soft skills, digital mindsets have to be inculcated. Integrate their production with marketing, finance, trading, and manufacturing, and be open to change. So these are the 9 steps these small to medium industries have to go through. This is the traveling, the step-by-step approach, moving from conventional manufacturing to intelligent manufacturing. Again, robotics and power of your internet and GIS connected devices system. Let me go through quickly these toolkits. These are the toolkits. One set is called MFTs, DSTs, RATs, CSTs. Manufacturing and fabrication tools, design and simulation tools, robotics and automation tools, sensors and connectivity tools. Step by step, these tools have to be introduced into small and medium industries. Cloud storage tools, CSTs, data analytics tools, and business management tools and principles. So I think I can stop here, and let me ask Professor Razali to come over here and tell us what you are doing at UAT and how Fawad Sahab आपके first time है ना? So Raza Sahab.
Give me a minute to bring it up. Sir, thank you very much. You've invited me. The basic, all right. One deficiency that we feel over the years is a little bit of a disconnect between the practice of engineering and the work that the universities are already doing. So when you came last day to the university, I found it like an opportunity to bridge that gap. So thank you very much for that. The other thing is that in universities, there is especially in Pakistani universities, there is a tendency to write research papers. And these research papers are obviously going to be on the boundary of knowledge, but not necessarily solving a problem of Pakistani industry. So that is a little bit of a disconnect that we feel. So I found your visit to be an opportunity to apprise you and this August forum about the work that we are doing to bridge that gap as well, to do something for the local industry, to provide certain tools which may be directly or indirectly used in Pakistani industry. So this is a little bit of context about this presentation. All right, so I think I can proceed with it. So the overall theme would be robotics and mechatronics, as you can see in front of you. And the work that we are doing in one department of UET, which is mechatronics department. Other departments are doing really wonderful work, but since I'm only representing one department, so I'll be restricting myself. So I can share it from here, new sheet. Yeah, I think. All right. So this is a little bit of context of this talk. So I'll be brief about our work, and we can have an interaction later on as well. And I've also written down this is a showcase of our recent work. So I'll not be going way back. So this is just like 2 years of work that we have done. The prior to that work, you may visit us and we can showcase that. So one thing that we have established recently is a robotics development lab, which is called Human-Centered Robotics Lab. I'm very much sure that this would be kind of a news to you that there is a National Center of Robotics and Automation in Pakistan, where they have 11 labs doing really wonderful work. We have one of those labs. And this lab has got this context of making these robots which are human-centric. And the idea, the background is that that we wish to develop smart sensing and actuation technologies, which are going to have seamless integration with humans working around them. So you must have observed that robots generally are caged in industry. So you're going to have a fence around them, and the robots are doing work in isolation. But the modern robots, what we call collaborative robots or cobots, are robots which can work with humans collaboratively. So it is something like you are shaking hand with a robot, and the robot is able to respond to your tactile feel and respond in an impedance control manner. The interaction. So a collaborative robot would necessarily be a robot which can respond to a feeling of touch. If you wish to move it with your hand, just like we kind of interact with each other physically. So it is going to be able to do that. In addition to being safe, in addition to being responsive. So this is what we wanted to do. But at the core of this work, at the center of this work, there must be smart sensing and actuation system, which can respond to that kind of control. So this slide is illustrating that we are trying to develop those technologies. And in that, we were able to find 3 technologies. So this lab, which is part of National Center for Robotics and Automation, aims to explore three domains. And you can see those three domains over here. One is the development of collaborative robots. The second one is the development of exoskeletons. And the third one is the domain of prostheses. So you would observe later on as well that in all of these three domains, there is going to be a human connection with the machine, whatever it is. If it is a prosthetic device, it is going to be used by a person with mobility impairment. And for that reason, there is going to be an interaction between a physical body of a human and a physical body of a robot. And you would see that this is the central proposition that we are exploring. So one by one, we'll go about it. Collaborative robots. Now, the basic idea is that when a worker is doing a job, there are going to be some specialty skills which are going to be the human's skills, especially in the assembly operation, because it is really a complex job. There is always this need of doing a job with some assistance, but not by replacing a human. So for that reason, you're going to find multiple places where you wish to use the, is there something to do? So we wish to kind of take leverage from skill of a human and then repetitiveness of apologies for it. So the basic idea would be that in such kind of jobs, are we going to have a robot which is going to do the job partially, and then the human has got the skill to do the remaining job. So in this particular scenario, you can see that the robot is able to hold in the illustration, is able to hold the door so that the gravity compensation can be given to it. So it would be bearing the load of the door, but the person is going to feel a relaxation to assemble certain objects in the door and do the job which is going to be otherwise really difficult and time consuming and labor oriented. So this was the context with which we wanted to I'm not sure what is happening over here. This is not part of my slide. And obviously we can have a question and answer session later on. And you can unmute. All the participants which have connected online, they're requested to please mute themselves kindly. And the guys who are doing kind of these placing these arrows, they requested to please not do that. Thank you. All right, so coming back to the point. So we thought about it, that what should be done in the lab. And we thought that there is one thing that we wanted to do something really modern and current and which is state of the art. But on the other side, we found that there is a need in the Pakistani industry to do indigenous development of similar technologies. So we wanted to kind of cover both the sides. And in this particular journey, we started with this version 1 of making a robot, which is a 5 degrees of freedom robot. It is capable of doing collaborative work, obviously, as I've already mentioned. So this last couple of years, we have developed this robot indigenously in-house in the lab. And this is industrial grade robot. Some features are being illustrated over here. It has got 5 degrees of freedom, which means that there are 5 joints in it. So the underlying engineering, the mechatronics engineering is the design of that joint. I'll further explain that later on. The payload is currently in this version 2 to 4 kilograms, which we can obviously increase. The maximum reach is about 1.2 meters. You can see that. The joint design, especially, it is our forte that we have developed in a different way in order to cover the modern development of the robots. And for that reason, this is a hollow shaft design. All the wires are going to pass through inside the joints. So this is something that we have done. It is based on BLDC motors, which are brushless DC motors, contrary to the existing robots which are developed otherwise. It has got thrust bearings. It has got harmonic drives in it. We have developed all the control paradigm ourselves. So all the engineering, intellectual property is housed inside the lab. And most importantly, we have developed this impedance control paradigm, which allows this robot to behave safely and collaboratively around humans. The communication protocol that we have ventured into is also modern, which is EtherCAT, contrary to the existing communication protocols, which are either slow for these kinds of robots or which are not really modern, which are losing their support gradually. So we have covered that side as well, that we wanted to make it really modern. And it is obviously a robot. Robot can be, I should emphasize this point over here, that the robot is a general purpose machine. We are able to change it depending upon the application. If application is in textile sector, we can obviously do that. If the application is in, let's say, assembly operation, packaging, machine handling, stuff like that, this robot can be programmed, and all the work that has been done indigenously provides us that flexibility. So coming back to the joint, this joint has got multiple parts in it. So rather than this, I'll indicate an illustration of it. So this joint, which are 5 in number for in our robot, is actual engineering that we have done. It has got the frameless BLDC motor. It has got the hollow shaft design. It has got all the encoders, controllers, drivers, all embedded in it. We have thrust bearings in it. So this joint has got the ability to be used in different places. Be it the robot that we have developed, be it, let's say, a legged robot which can do service for the elderly. It can be used in prosthetic devices, and you'll see that later on. Just give me a minute to remove possibly. You guys can train your eyes to just filter it out. And if it was my class and my student would have done it, I would have been really, really tough on them. All right, coming back to the point. All right, so this is where I should spend some time. You know, that making a robot which can do the job, and I have a video of that. You will see what this robot is capable of. But what is happening in the background is going to be really interesting to know. So generally what happens is that a robot needs to solve the path, and what we call in engineering terms, it is path planning exercise. It is a computational effort in order to find the most appropriate path from the starting point to the ending point, irrespective of the type of application that the robot intends to do. Or in other words, in simpler words, any user should have the ability to give any kind of path to the robot. And the robot should have the ability to take that path, solve it internally, mathematically, analytically, and then give to the machine elements of the robot. But that path, which has been performed or given in the workspace, let's say I'm moving my finger, and the tip of the finger is something like I'm moving in 3D space. If this is the path, that path is in the workspace, and the robot would not know how it needs to be translated, so that each joint can be can understand the motor command. So we have to translate a 3D path into joint related data, and that is what we do in inverse kinematics, and you can see that happening over there. So we can make any robot, and we can do inverse kinematics indigenously in-house by the lab, by the engineers. And we have done it for our robot and multiple versions of those. But this joint command, these joint commands are needed to be given to all these joints which are going to be big or small. For example, the joints at the shoulder are going to be much more powerful as compared to joints on the wrist, which are going to be really delicate. So depending upon the nature of the joint, the control command is needed to be translated. And that's what we do in motion control part. So this is the second part of it over here. And then obviously the torques are going to be, the reference torques are going to be given to the robot so that the robot is able to perform in physical world. So this is what we do in simulation, as well as hardware in the simulation part, as well as everything done on the hardware. So we have covered all the three basics on that. Then obviously when robot moves, it moves in terms of moving the joints. So this joint, the shoulder joint, the wrist joints, all the joints are going to have movements, but these movements are needed to be fed back to the system. And these are generally recorded by encoders. Encoders give real-time data to the controller, and the controller should have the ability to resolve back to the workspace, because joints are moving, but what is going to be the effect of moving those joints in the 3D space, whether it is matching that profile that we have given initially to the robot. So that is what we call forward kinematics, and we are able to do that as well. So this is needed to be solved not once, not twice, hundreds of times in a second continuously. So the system should have the ability to do that. So that's why the development of robots at industrial scale, we can do it like a demo version for let's say college kids, but actually for industrial grade robots, this is needed to be done at really a fast pace. And that's why we have done the EtherCAT communication protocol for it. So this is once done, the robot is able to do the job real time, and you can see that happening in the simulation world, simulated world over here. And this you would see that happening in the real world. So I'll ask you guys to see the physical real manifestation of the robot that we have made. And this is version 1. Version 2 is still in the progress, and you will see those progress over there. So this is our lab. This is not a showcase lab. When you're going to visit it, you will find that there are dirty corners. People are doing their work, but the work is really speaking for itself. So this is one of the demos where the robot is able to perform the job, and you will not see all those wires coming out of the robot, and the joints are really industrial grade joints. And we can have a discussion on it, that how can we commercialize it, taking advantage of, let's say, a manufacturing facility or production facility in China, and maybe we can kind of strike a collaboration over there. So the background work, starting from selecting motors, all the way to making joints, all the way to forward inverse kinematics, and the dynamics, everything is done by the team. Manufacturing of this prototype has been done by the team, all in the last 2 years. This version that you have just seen, I'll have another slide to further illustrate that. That is the next version that we are making. We have made 3 joints already, but we are going it to the 7 joints in order to make it truly collaborative. All right, I'll move on because I've spent much time on it. So this is the version 2 that you can see over here. Rather than having 5 degrees of freedom, we are going to have 7 degrees of freedom in it. And that is truly what is going to give a degree of redundancy in the robot. So just to give you a little example, that if you're saying prayer in let's say in a mosque, and you're in the performing your sajda, and some fellow Nimazi has got his elbows out, you'd automatically adjust inwards in order to make room for it. So this robot, with the 7th degree of freedom, is going to be able to do that. If some hindrance comes blocking the movement of the robot will have the ability to adjust itself to reach to that place. So that is the benefit of adding a degree of redundancy in the robot in order to make it much more capable. So, but obviously it is going to make the complexity multifold in the engineering complexity. And this is what we have established. So on one side, the 3D model is being shown, and on the other side, it is the yesterday's image. We have integrated 3 joints in it. It is much more sleeker as compared to the first version, but much more powerful. And we can further increase the power. And by the way, I should also emphasize that the collaborative robots are not really doing heavy lifting, but we have the tools to develop those robots as well. So this payload of 2 to 4 kilograms is just for the collaborative robots. It is not something illustrating our capability. It is illustrating what is needed for the collaborative robot. Now I should move on to the second domain that we are exploring, and that is the exoskeletons. So the basic premise was coming back to the original premise that can we do something for the local industry, and can we do something real which is really modern as well, bridging the gap. So in this particular realization, what we wanted to think about, that the workers are doing their job, rather than removing the worker from that place, can we assist them? Can we give some sort of tool to the worker in order to avoid muscle fatigue that may creep in? So when you do a repetitive job, with repetition comes the muscle fatigue. And we wanted to kind of address that. And we have certain tools to do that. But we wanted to do it through exoskeletons. And this was the kind of starting discussion on it. But now we have developed 2 versions up to this point. First one is over here, and you can see this is 1 degree of freedom version. It can do gravity compensation. Now you know that gravity is the biggest blessing, one of the biggest blessings, but gravity is also one of the biggest curses. When you have to lift something up, you have to lift against the gravity. And that's really, really troubling for industrial workers. So if we can have a device which can compensate for gravity, and the person is able to do the remaining job. So if, for example, I'm moving my hand, arm, like in a free motion, I will not be feeling tired about having repetitions on it. But if I'm holding, let's say 5 kilograms, and I'm doing, let's say, hundreds reps for it, obviously the fatigue is going to creep in. So we wanted to do something like this, that rather than having a motorized version, can we do a passive version without having any motor in it, without having any electronics in it? But can we do it in mechanical way to compensate for the gravity? Because we know that gravity is going to always come pull downwards. So for that reason, we have made the first version and second version of the gravity compensator. It can have 2 to 10 kilograms of weight lifted up. And you will just kind of move the handle, which you can see over there. These handles, if you can move it with your fingertips, but the load is going to be carried by the device. So let's say in assembly operations, where workers are doing this assembly operation repetitively, lifting heavy loads and plugging them in different places, we can do it through these means, and the worker would not feel that much tired about it. And the basic engineering, because you guys are coming from engineering background, the difficulty in that is to maintain the isoelastic behavior of this mechanism when you go down and when you go up. So in this range that we have given over here, plus minus 45 degrees, 45 degrees. So you can start from here and you go down there as well. So in this whole range, whether this behavior of the passive exoskeleton is isoelastic or not. And this is what we have established by designing the spring and the connected mechanism in it. So this is done from the theoretical base all the way to physical development. So this was one part. So because I don't know how much time I've got. So I'll wind it up because otherwise, you know that I'm speaking too much. But this is one part of the exoskeletons. The other part is to do, can we do it like in active exoskeleton mode as well, where you have the motors, where you have the active actuators imparted in it. And remember, we started our discussion by saying that the lab is able to do smart sensing and actuation. And in this realization, you can see that we have the model of it and the physical version, which is the first version with 3 degrees of freedom is given over there. We are testing the control paradigm on it. So in this particular scenario, on the handle, you can do normal movement, and the exoskeleton is going to give whatever compensation required, not only the gravity compensation. If something is pulling like this, it is going to be able to respond to that. If something is pulling up, it is going to be able to respond to that. So whatever is the hindrance, it can respond to it because it has got the intention-based control paradigm implemented in it. So these are some illustration and the physical realizations over there. I think this is a video you can see without human, it is able to do that. So actually this is also a robot, but since it has got the force torque sensing resolved back to the joints, so it has got the ability to do the exoskeleton work. The biggest challenge in this case is that how can we do the control paradigm in real time? And that's something like an engineering challenge for has been an engineering challenge that we have resolved. Now coming back to the third and last domain of the lab, active processes. And in active processes, the idea was to facilitate persons with mobility impairments. And then we focused on the lower body support. And you can see that this is the first version of the ankle that we have made. It is not the passive processes. It is not something like a fixed, not moving prosthetic device that one can wear, and it is just like an extension of a limb. It is an active prosthesis which can respond to different stages of movement. So just to give you a little bit of illustration of that, if I'm going to walk, I'll have a T8 contact force, and I'll have a push-up phase, and then I'll have the toe off, and then I'll have a free swing as well. So the push-up phase is going to be really, really different from the heel in contact is going to be different from the toe off. And when you move your foot and you transfer your weight in that intermediate stage, it is going to be really performing differently. So the basic idea is to allow this active processes to respond differently in whatever stage the person is in. So this is for level ground walking, but what about if you are going to climb the stairs? What about you are going to descend from the stairs? What if you are going to have the ramp up kind of scenario, ramp down, sit to stand, stand to sit? So different paradigms we are able to respond to it. So this is just like a brief specifications of the work that we have done, the engineering work that is at the background. So this particular processes, this would be interesting for engineers to know that when we walk, there are going to be certain stages where we can conserve energy. And there are going to be certain phases where we can release that stored energy to give benefit to the motor. Otherwise, and this is really a marvel of nature, that the muscles are able to carry that heavy load without complaining about it. But when we try to do it in a motorized fashion, we come to realize that we truly are, humans are really wonderful creation of the Lord Almighty, uh, because the most powerful motors will find it really difficult to carry a heavy person. So what we have done in this particular scenario is to kind of store energy wherever available and release it wherever that is needed. So this is the background engineering that we have done. And this is not something like we have done in one go. We have done in an iterative fashion. We have the 3D printing facility in the lab. We have good 3D printers, and we have the fabrication facilities, some facility in the university and some facility around different places in Lahore. And in a gradual process, we have reached to this point where we have the prototype of the processes in front of us. So a little bit of illustration of it. We are still in the control phase, and you can see that we are able to give motor commands and it responds according to the specifications. Obviously, the final version is going to be variable. Obviously, there is going to be a socket which can be designed according to the person for which the processes can be tuned. And this is a general purpose prosthetic device. We can control all the parameters to fit with the needs of a specific person. So a general purpose device which can be tailored from an operational standpoint for any patient. And we have done this for knee as well. So ankle is what you have seen. This is the knee version of it, and we are testing the two in this stage. So the remaining 2 months, we are going to spend time on. We have identified the volunteers. We have got their consents as well, and we are in the next 2 months doing the lab experiments on it. So if you wish to visit us, this is the lab in the Research Center of UAT Lahore. Do drop a visit. Feel free to come over there anytime. The lab members, if I'm not available, they are going to give you a warm welcome and will show what we are doing. And I'm saying it because otherwise you guys are sitting over here, I'm standing over here. God knows. God, kindly mute. You guys have requested earlier. Can you please do it? Thank you. So this is one thing for one lab that we have developed, but there is another lab that we have developed recently, and this is all in the mechatronics department. Last 2 years have been really busy for me and for my colleagues, and this lab that we have developed is in collaboration with Hamad Medical Corporation, Qatar. We got a funding from there. So this is a HIA lab for mechatronics and resuscitation research. So this is different from robotics, but this is related to humans, obviously. It aims to facilitate them in one way or the other. So the idea was to develop smart and marketable mechatronic devices which are going to provide aid in resuscitation practices. Resuscitation means that if some person is not responding medically, we generally provide CPR to it. So it is a cardiopulmonary resuscitation. You must have observed that you give them emergency aid on that, and you provide cardiac movements on the sternum, and you provide the pulmonary part with the ambu bag or from mouth to mouth resuscitation. So we wanted to do it in a mechatronic way, and we wanted to do it in and out of hospital settings, and thus saving precious lives. So this was the ultimate objective of the lab, and obviously we wish not to stop over there. Whatever is the periphery, around the periphery of this central idea, we wish to then explore that as well. So this is Pakistan's first direct foreign investment receiver lab in resuscitation research. We have completed one part of it. I'll just briefly showcase that. So am I muted or? All right. All right. So in this particular slide, you can see that now the basic idea is, I'll just briefly apprise you guys. When you do manually, and I'm very much sure that some of you guys may have observed it or may have practiced it. If you're coming from engineering industry background, they do these exercises for resuscitation on and off. So manual resuscitation is really tough. Generally, the practice is for 45 seconds, one person does the resuscitation, and for the next 45 seconds, the other person comes in place of the other. But there are now some machines which can do this job in a mechanical or mechatronic way. So what we observed, that these machines were just able to mimic or kind of copy the mechanical movement process, not actually understanding what is happening in the inside the body, what is needed truly for resuscitation. And that is really tough because obviously these are going to be live humans. We cannot really do experiments when someone is in need. We have to save the life. We are not going to subject that person into some engineering or some exploratory paradigm. And obviously we don't have consent for that. So the basic job is to save a life at that particular time, not to have kind of data generated out of it. So what should we do in that particular scenario? So we wanted to kind of think about it, and we found an interesting way to do it. We said that, can we make artificial organs, not for the sake of replacing the actual organs with the artificial organs, but just like mimicking the fluidic characteristics of that organ, so that we can have a simulator developed over here. And this particular simulator that you can see, this is what we started designing last year, and we have successfully designed it. So all the organs, the heart, the lungs, the abdomen, the legs, all the organs are matching the compliance and the characteristics, the mechanical characteristics, the fluidic characteristics of actual organs. And we have made these soft valves as well. So from one organ to the other organ, whatever is the pressure drop, we're able to mimic that. We're able to simulate that physically. So we have developed this open multi-organ soft cardiac circulation system, which mimics the exact parameters of blood circulation in a body. Rather than having actual humans under experimentation, we are able to do it in a separate way. So this is first of its kind. And on top of that, we developed this new paradigm of resuscitation research, where we found out that yes, we can find a better way of resuscitating the humans without spending that much power, without breaking the rib cage, without physically hurting the person under CPR. And we have increased the efficiency as well. In one parameter, we have increased the efficiency to more than 60%. And for that reason, we are presenting this work in European Resuscitation Council this June in Belgium. And we are really hopeful that this is going to come up with, this is going to be eventually leading towards finding new machines doing much better CPR as compared to the conventional machines. And obviously, these are going to help to save lives as well. And obviously, I'm not the only one to be praised. Obviously, there are our fellows in Qatar, as well as my RA, who's done kind of really wonderful work in that. And now we are doing the animal studies. So this is the current state. So next stage of product development is to do the same paradigm on animals. That study has been approved by Qatar. And we are going to do this year those animal studies, and hopefully next year we are going to find this product really being tested. Moving on. All right, so So just like quick experimentation. So this is one of the machines which are available. We are mimicking that at this particular stage. We generally do two-stage process. We do simulation in a physical and physics-based engine, and then we do it physically as well. So this is one of the other settings. There is a machine which is called Autopulse. This is mimicking that. And obviously there is a data acquisition part to measure the blood circulation and all the pressures and all that. And we found one combination for us. We have made one machine. I'll just quickly go through that. We have done some other work as well because I'm spending too much. There is this hyperbaric hood that we have made for Qatar as well. There's this temperature control device that we have made for hypothermia treatment. Obviously we are not limited to CPR simulator and all the resuscitation research, mobility profiles, and multi-chamber smart mattress we have made, two-lead ECG device that we have made. We are doing some gait analysis. We have, by the way, a motion capture arrangement in the lab. So whatever movements that we wish to capture, we are able to do that. We are developing our own EMG sensor. We have a few available hardware listed down over here. So one last concluding remark on that is that I started my talk with this underlying observation that there are going to be good labs doing really good work in universities, not only my university, in NUST, in GK, some other places, but generally the engineering community is not kind of aware of what is happening in those labs. We are working in silos. We are doing work in isolation. And this is because the nature of research work is like that. We wish not to present ourselves in front of the whole world because we are intrinsically shy to face people. But we are good in doing work on the table, on workstations, in the labs and all that. But sometimes it is really necessary that we should come out. And if we are shy in coming out, you can visit these universities. You are coming from different universities, and I'll invite you guys to go visit your universities and see what is happening over there. And if those are matching with your skill set, if that area is really related to what you have been doing in your life and you can give some leverage to that work, please do that. And if we are not going to do that, then obviously we are going to keep on importing all the technology from outside. We are always going to be kind of dependent on others' technology. We have to do it like indigenous development in-house. Once that indigenous development has been done, we can get leverage from manufacturing in China and other places to get those products back to Pakistan. So this is what I'm really passionate about. So that's why I'm pleading you guys to kindly do visit your labs and see what is being done over there. The other thing, just to give you a little kind of a numeric, a quantitative analysis of it. A few guys from Nestle visited our lab. They told us that 1 year service contract of the robot that they have developed, that they have deployed over there, is 5 million Pakistani rupees. All right? 1 year service contract, not the product, only the service contract is 5 million. And we have developed the whole robot indigenously, all the skill set available in-house in less than half of that. And obviously there is an R&D work. It is not something like a production price of it. If we get into production, it can be much lower than that. So just to give you a numeric number in that. So in this particular scenario, I would plead you guys to kindly do visit your labs, visit our labs, and if you're able to kind of give us that leverage, give us that last in a relay race, we have ran 300 meters. But the last 100 meters, with your help and with your links and with your efforts, we can do wonders. So this would be the last plea before I leave. Thank you very much for giving me this opportunity. Thank you. Should I unplug my USB or? All right. Thank you. I can do that. जी मैं आपको यहाँ से आपको no worries on that. I can give you a PDF of that. That would be really nice way to do it. Thank you.
So, Dr. Saab, thank you very much for coming over here, spending time with us. And we see how much backup we have. We have this backup of Mechatronics Department of University of Engineering and Technology, extending their know-how, their services to the industry. And as we see, our participants are ranging from 70 to 80. Then these participants who are online at present, you'll be surprised where are they from. You will see they are from Quetta, from Khuzdar, from Karachi, Hyderabad, Sakkar, Faisalabad, Multan, and Gilgit, Peshawar, Laya, Faisalabad, Lahore. So we have quite a spread around. Now, who are these people? These are engineers, and these are young engineers who are looking forward to a career. They are looking forward to utilize this new technology, and how can they apply, go into the industry, how they can apply this technology into the industry. So these are the people. This is kind of a regiment that we have created of 70 to 80 people. And at the end of this conference today, the workshop today, they will be issued certificates of participation. We will call them professionals, certified technology engineering professionals. So they can take the certificate, go into the industry, have a kind of confidence building into the industry, and tell them that this is the potential, this is the technology I can bring to your industry. And this is the backup from the University of Engineering and Technology, and this is the backup from our Chinese friend, Ms. Chao and Wai. Can you understand what's going on here? Are you with us? Yeah, sure. Now, we will call them as well. Mr. Fawad will tell us. Now, you will have your turn. This is a promise that I did in Karachi. Garaisa, you are a witness to it, that I promised to people in Karachi that we will have a workshop, and it's a knowledge sharing workshop, and we have about 70 to 80 people here, and they can do a lot. They walk into industries, walk into small to medium-sized enterprises, and be a liaison with engineering universities, laboratories with Chinese collaborators. And I also have a promise made. I have a promise made to the international coalition of that we have a part of, and I have to show them what progress we are making. I have to be accountable to them as well. So we are making this progress in Pakistan, that we are bringing technology right to the doorsteps of our small to medium industries, rather micro industries in the small villages, towns, Sakkar, Faisalabad, Quetta, Khuzdar. It's all there. Madam Shaila, welcome that you are here. And Madam Shaila is really the director of this innovation incubation center, and we have a joint venture with her company, that is Management Excellence Consultancy. The Management Excellence Consultancy, we don't really have that kind of excellent jobs to conduct. We have to go right to bottom lines of our workshops, production centers. People are so they need technology so much that you will be surprised. And I also had a promise made to civil engineers, so that till now we have been talking about factories and production, mechanical engineers, and mechatronics. But I also have a promise made to our civil engineers. So what use they can make of these technology instruments into infrastructure, into civil engineering. So what they can do in civil engineering, how can they use these technologies and do something good. This is a set one, so we got to go to the set two. Then इसको निकाल दे, come out of it. इसीलिए तो यही तो है, इस यूएसबी में होगा ना। सेट टू नहीं, कॉपी तो तीनों दोनों ही कर ले, लेकिन नाउ वी रनिंग सेट टू. That's it. Smart infrastructure technologies. As far as infrastructure is concerned, infrastructure means roads, water supply, sewerage systems, telephones, lines, gas, parking. And look at our small cities, places. The terrible situation is there. The parking situation, congestion on the roads, traffic problems, accidents, and water shortage. Even in large places, there is water shortage. And pits on the road. Roads are in terrible situation. So for how long are we going to wait that somebody will come and they will do this infrastructure for us? How long? We have to step out, do a direct action ourselves. take all this in your own hands. We need a group of young volunteers, professionals who stand out, come stand right there in the community and offer their services on a complete package basis. And today, because of these technology instruments, devices we have, connectivity we have, we are able to gather stakeholders together. I'll go through these slides one by one and see how this can be done. So this is regarding smart infrastructure. Now, what does it include? We are focusing on small towns and even small localities in large cities. Transportation, energy, buildings, water and wastewater, waste management, public safety, education, healthcare, everything. You see, all this has to be addressed. We need to train our engineers, equip them with the right kind of technologies so that they can stand out on the street and initiate projects themselves. I think they can. So there are facilities, there are these platforms available in a smart context. This is called smart infrastructural technologies. And we'll go through them. We will see that there are platforms available which you can use to introduce improvements in the infrastructure. इसको क्या मैं कांटेक्ट कर लेता हूँ. SCADA is a platform. Some of you might be already knowing this. SCADA means supervisory control system, and it is a computer-based analytic system. And if you have SCADA with you, you can do a lot. I'll just let you know how much you can do. SCADA really means connectivity of these databases, analytics with IoTs, devices, systems, and all interconnected together to develop and to integrate a system that is meant for infrastructural development. So this is really all about it. It's just controlling and monitoring. SCADA is a very powerful platform you can use and lay your hands on it. I think our technology support professionals that we are building can make themselves very much at home and get hold of this platform, be connected to it, and then you can see that you can do a lot. Kind of like emergency management system. Emergency management really means predictive analytics and shared data resources and awareness. And this is a system you can prevent accidents on the road. You can locate them if accident occurs. If an accident occurs, you can locate. And then you can inform the emergency services, and they can be right there on the spot. So this is a platform that can be used. There is basically there is a device in the vehicle, and that device connects to the mobile in the driver's possession, and connect to the department of the concerned department of the emergency unit. So this is all connected system. Any time a vehicle meets an accident, that device that is built inside that vehicle gives a signal, an alarm. An alarm goes around. It tells the driver as well, and tells the department concerned. So this is one way. I have to technology enablers in transportation. Parking. There is a digital parking system. You can use this system, and the drivers would know where to park their car. They will get a signal on their mobile that such and such place is available there for the parking. So you don't really have to park anywhere you like. So this is a system, a very handy instrument, technology instrument, and it doesn't cost much. It's only an app, a Google app in your mobile. And there is a platform which connects. Any vehicle coming into that area will be shown where the parking is available. It's interesting. Similarly, energy management system. We have this is done by SCADA. SCADA is a very helpful device. It's a platform really, and it manages. It controls, it manages the energy utilization in a locality or in a community. Smart lighting and smart lighting systems, automatically controlled lighting systems in buildings. So there is a platform for it as well. So you see, all these facilities are available, these platforms are available for smart working of infrastructure. You can get hold of them and avail these platforms and extend your services to communities. And this is the right time. This is for the improvement of infrastructure. Similarly, there is a platform for healthcare. I think some of us already know about this healthcare system. There is a system that is called citizens engagement, tourism and economic development. A system is already there. You have to plug yourself into it, and citizens can interact with each other in a community maybe. They can talk to each other. I mean, this power was never available before. A community really becomes a community, a talking community. With just this mobile in your hand, you are in touch with your community. You can talk, you can loop yourself together and talk about it. So this system also helps tourism, and this is also works for economic development, public safety. There is a system which enables you how to ensure public safety at security positions, security points. If there is an incident in town, you will you'll come to know which route is more safe than the others. So you see, all these platforms are available and the facility is there, technology is there. All you need is to get hold of them and be a technology provider, be a sport professional, and serve your community to the best extent you can. Similarly, there are platforms available for dissemination of education in schools, in colleges, universities. Systems are there in government services, their data control, their recording, documentation. Right. Okay. So I think let me stop here. Water management, sewerage, waste management. This will be a good idea, Ahmed Saab, to distribute these slides to all participants. And I can now stop here and call our friend Mr. Fahad and Ms. Mai and Mr. Chow. See what they have to say. And we have about 70 to 80 participants all over Pakistan. So you have a chance to address to them. We are all friends together, we collaborate with each other, and we help each other. Build a resource together. So, Mr. Fahad here.
Bismillahir Rahmanir Rahim. My name is Muhammad Fahad Abbas. By profession, I am an educationalist, and my expertise are in kindergarten, primary, and secondary education. I belong to Zyka's school system and serving as managing director. Zyka's is the first school in Pakistan which inaugurated Chinese language in 2017. So we are pioneers. We are having HSK all levels, Chinese spoken, and robotics in our campuses. My team is here. Ms. Gao Yun Mei, she is Chinese language instructor. Mr. Zahu, he is electrical engineer. Mr. Asad and Shoaib, they are from UET, from robotics department. I'm very thankful to Mr. Javed, who provided us chance to work with this prestige institution. What we want together to work and to serve is to impart Chinese language to our youngsters, to young graduates, and the newcomers. We intend to provide them Chinese language, spoken language, Chinese culture, and the education of robotics. This is very crucial time. Right now, it is very crucial time because government has banned imports. So if imported things not entered in Pakistan, it means we have to provide a place, we have to develop industries where we can produce products like this. So this is right chance when Chinese community They want to come Pakistan, they invest money and open their industries. So we should prepare ourselves in advance to prepare our youth, because this institute already has different disciplines of engineers. We just shape up them with the culture of Chinese, and we are ready to serve anytime. For example, 60 participants of LUMS, they are recently graduated and coming in this institute as internship. So we can provide them Chinese culture, Chinese language, because more than 70 factories are owned by Chinese native in Lahore. These industries are light industry, like all sort of energy savers and SMD lights, all sort of handles, locks, door lock, window lock, or any domestic or professional locks. The buttons, garments, even mobile factories are owned by Chinese in Lahore. So they need staff. What sort of staff they need? You people are belongs to engineering background, but what they Chinese need is they need guards, they need drivers, they need cooks, they need other people for their help, those who little bit understand their culture and they can speak easily. You know, when we meet any Chinese people and we say them ni hao, they feel so excited that you know our language. So as they are here, so it is our moral responsibility to educate ourselves first and to serve together. So in this contest, we are here. We will sign an MOU with Mr. Javed and his institute, and under his great expertise, we want to start a recent batch in June, in which we will impart Chinese language and robotics. So I would like to introduce my team. I request Ms. Gao Yin Mai to please come here. She will say something, I will translate, then I will call my robotics team. Ms. Gao Yin Mai, please.
大家好，很高兴受加维斯先生的邀请来到这里。我是来自中国上海。
I welcome Mr. Javed and his institute. I came from China and I am language instructor.
我的名字叫高云美。我现在跟大家说一下，探讨一下中国现在的发展。中国在科技方面非常先进。
My name is Gao Yin Mai. I am here to introduce Chinese technology and advancement with you.
我们在这里呢，可以向你们介绍中国的科技、中国的文化和中国的成功秘诀。
I am here to tell you how China is progressing all over the world, how much technology they are using.
现在巴基斯坦的政府已经禁止很多的产品到巴基斯坦。
She is saying that right now import is banned and so many things will not enter in Pakistan.
所以现在很多的中国人和巴基斯坦人也想在巴基斯坦建厂。
She is saying that Chinese people will not sit silent. They will must come here and invest in this market.
我们需要人们了解我们，并与我们合作。我们所做的就是帮你们在学习汉语中增强你们的汉语水平。
In the preparation of their presence here, we have to work hard in advance and to know each other.
大大提高了你们这个交流的水平。跟我来的一起的赵总，他们就需要很多这样的人才。
She is saying that as she belongs to Pak China commerce industry, so whatever the industries will open and already has opened, she will introduce your children to go over there and work.
让你们在以后的事业中呢，就是更顺利的发展。我所说的就是这些，谢谢，舒格利亚。
She's saying that I will feel pleased to serve you people when you will graduate and learn Chinese and you will able to work over there. You work over there. I will feel happy. Thank.
Okay.
Now I would like to call Mr. Asad. Please come. He is robotics in charge in Zycas, and they made small models from raw material, just like we have seen these water bottles. With the help of these bottles, Dr. Raza Ali, you know better that how small children from age group of 3 to 13, how small projects they can make. Please, Asad.
Good morning, everyone. 1 minute is left in the morning to be over. I hope you're all well. Thank you very much for this opportunity. I was once going through my Facebook and I saw a post in which there were two statues. One statue was of a thinker, the other statue was of a doer. So it was funny to see that on the statue of the thinker, there was a whole statue, but on the side of the on the side of the thinker, there was a whole statue, and on the side of the doer, there were only steps, which meant that the guy was already busy doing something. So we are a team from UET. We belong to the Robotics Department, University of Engineering and Technology, in collaboration with the National Center of Artificial Intelligence, a government body created back in 2017 by NAST. So our directors are quite visionary, and they said that we want to make a contribution in today's society, in today's Pakistan. We want to equip children, the graduates, undergraduates, the students of schools. They should know how to make robots. They should know how to use robots, because the future is of robots. Everything that will happen in the future will happen with robots. We're developing at such a fast pace that we are even expecting to see transhumans in the next 10 to 15 years, which means that half of us will be robots and half of us will be humans. So that will be good. I see it as a scary thing, but it's inevitable. It will happen with time. So the sooner we adopt to it, the better it is for us. So what happened was that we collaborated with Zakar School System with Honorable Sir Fahad, and he's also a very visionary guy like our director in UET. And he said that we have to go into the market and we have to provide it on a massive level. So if students come from an engineering background, we're there from them. If they're from the electrical background, we can also provide trainings to them, and multiple other. We are equipped and skilled in providing trainings on artificial intelligence, on computer vision, on machine learning, deep learning. We are skilled, our trainers are skilled in making expert systems, soft ports, recommanders, and task automation systems. And apart from that, we try our best to, because, one side of work is the technical or the work side that we do, and the other is the soft skills that we also try to embed in our students. So apart from providing technical trainings, we also motivate them that they should go out in the market, or they should go out in their peers and families and try to sell that robot. Again, that was the idea of Sir Fahad, that he conducted one fun fair in the school, and the students were till then they made some robots, and he told them that they should go out in the crowd and sell those robots. So that was a very good idea, that how you should learn the technical side and the soft skill side as well. So we are there, we are ever ready. Our teams are led by PhDs in the University of Engineering and Technology, like Dr. Ali Raza himself. He is doing a great work in the robotics lab. We are headed by Dr. Usman Ghani Khan and Dr. Waqar Mahmood, and in collaboration with the Zakar School System, we are ready to provide trainings in the market on robotics course to graduates, undergraduates, and school students. So that's about it from my end, and thank you very much.
Let me thank Mr. Fahad and Mr. Mai and Mr. Chow and the students there from Mechatronics, UET. Thank you very much for being here. And we work together and we'll, inshallah, get results. So I'll now request Shaila Sofan to introduce, what plans we have, what we are going to do, and how we are going to organize training, further training sessions.
Assalamu alaikum and good afternoon to all. Iyyaka na'budu wa iyyaka nasta'in. From the platform of Institute of Engineers Pakistan, I welcome you all, and I'm overwhelmed with the vision and with the feeling that yes, change is there and we are going to do miracles, inshallah ta'ala. Because we cannot become what we want to be if we stay at the stage what we are right now. You know, change is inevitable. Change is the only constant in the world. And if we do not adapt to it, and if we do not look at it and we do not change, things are not going to be good for us. You must be knowing Charles Darwin, the naturalist, the biologist. What idea he gave? He gave the idea survival of the fittest in the world. I don't agree much to it. Today, it is the survival of the most adaptable. The person who can adapt to the changes around is the one, despite of not being the fittest, he'll be the one who is going to survive. Taking the same vision forward, I, from the platform of Management Excellence Consulting, that is my own company, came forward, and I was very happy when I talked to Dr. Javed Uppal. He being the mentor and he's the visionary mind behind that we are in joint venture right now sitting here. Okay. Okay. So from this joint venture, today we are sitting at Innovation Incubation Center. These are the two things, the ideas are combined together. We all know the importance of innovation. It is there, it is required, but through a system approach. And then incubation, we are going to flourish the ideas of innovation for this engineering community. Institute of Engineers Pakistan is covering, mashallah, it's the earliest and the longest department available for the engineer platform. And here today we have devised something that is going to change miracles for the engineering community for Pakistan. Today's lecture has been technology integration of in the engineering solutions. Currently, what is happening? Everyone is doing their own nodes of technology. Everyone is aware of what is AI, what is IoT. We have to bring it in here. But have we embedded it in the engineering applications that are currently working? No, that is a big gap that we need to work on. We have our IT industry booming. In the past 2 years of pandemic, which industry has survived the most? The software industry. Why? Because they connected to the foreign world. It was easier for them to go over there. Have we ever thought of that our engineers, those who are graduating out, their minds, their analytic ideas need to be tech integrated? So we are going to build that. And upcoming soon, inshallah, from June onwards, we are going to have entrepreneurial boot camps. But they are not simple entrepreneurship, they are technopreneurs. I'll be the technopreneur and we are going to give them those ideas which are tech integrated. We are going to connect with the software industry. We are going to have these robotics added in, but where? For our own root level engineering applications that are working. For that purpose, as Fahad said, yes, the engineers are the cream, they are the builders, they have to build the economy, but only if they are building their applications with the latest technology trend. So keeping the same mind, we all know three pillars of business process: people, process, and policy. And for people aspect, again, it's the soft skills, it's the analytic mind, and yes, it is the technical skills. Bridging the gap, we are going to do it. Our 60,000 engineers who are said to be jobless these days, we are not going to make them job seekers. We want them to be job givers. They are going to be connected with those people who are doing engineering industry. With that, I say that yes, Fahad, thank you so much for joining us. It's been just great, and we are going to have lots of collaborations with you. So our next calendar for the next 6 months is going to be there, and you are going to be on board. We are really happy and we are very much excited to share with you our plans of soft skills. And yes, of course, we are going to have teams who are going to volunteer as well as register with us, and things are going to be these boot camp graduates, they are going to do miracles, inshallah. You'll come to know that their analytic minds, how they are going to be integrated into our building the economy of Pakistan. And since our all Chinese are gone, मैं एक छोटे से शेर से इख्तिताम करती हूँ. परों को खोल के जमाना उड़ान देखता है, जमीन पे बैठ के क्या आसमान देखता है. आपको पता है कि whenever कोई बिजनेस को भी रन करना है तो पायलट रन क्या है? पायलट रन होगा, एक वायबल प्रोडक्ट होगी तो उसको आगे कोई आके वेंचर कैपिटलिस्ट लेगा. तो पहली उड़ान तो लेनी पड़ेगी हमारे इंजीनियर्स को, जो कि आगे जाएगी, वो वायबल होगी तो आपके पास आगे किक्स का प्लेटफॉर्म है, यू हैव लॉट्स ऑफ अदर एंटरप्रेन्योरियल प्लेटफॉर्म्स और पीपल आर देयर, आपके पास फंडिंग भी अवेलेबल होगी. पहली चीज तो खुद लेके आनी है हमने, क्योंकि कुछ नहीं होगा अंधेरों को बुरा कहने से, अपने हिस्से का दिया खुद ही जलाना होगा. बहुत शुक्रिया जी.
सेट 3 लगा दो, स्लाइड सेट 3 जी. ये हम सुन रहे थे शाइला सफवान को. मुझे याद आ रहे थे जावेद कुरैशी साहब. पता नहीं, I don't know how many of you know him, but I had the chance to work with him. He was sometimes a commissioner at Faisalabad, Javed Qureshi. And then he held various secretarial offices in Punjab. And ultimately, he was chief secretary of Punjab. And beautiful person he was, although a bureaucrat, and bureaucrats have their own stiff-necked approach to people. But he was, I found him a people lover, a man who sat with the people and worked for them, felt for them. And he was a poet as well. And Shaila Safwan has made me remember him. And his short piece I can also share with you. आशियाने की बात करते हो, दिल जलाने की बात करते हो. आशियाने की बात करते, आशियाना, this country is our आशियाना. We don't take it that way. Maybe we still think that it's somebody else's country. But right here, this is our country. We have to get hold of it and work for its own survival and betterment. आशियाने की बात करते हो, दिल जलाने की बात करते हो. ये जावेद कुरैशी साहब के बोल हैं. हमको अपनी खबर नहीं यारो, तुम ज़माने की बात करते हो. बहुत सही वर्ड्स उन्होंने इस्तेमाल किए हैं. यही हाल हमारा इस वक्त हो रहा है. हमें अपनी खबर नहीं है. हमें नहीं पता ये जो प्रोपेगेंडा हो रहा है इसमें सच क्या है और झूठ क्या है. हमें अपनी खबर नहीं है. हमें बताया जाता है कि जी ये हो रहा है, ये हो रहा है, ये हो रहा है. हो क्या रहा है? वी डोंट नो. हमें अपनी खबर नहीं यारो, तुम ज़माने की बात करते हो. हादसा था, गुजर गया होगा. हर चीज जो होती है उसको हम हादसा कहते हैं, गुजर गया, खत्म हो गया. हादसा था, गुजर गया होगा, किसके जाने की बात करते हो? लोग आए हैं, लोग चले गए हैं, किसके जाने की बात करते हो? और भी जो आएंगे वो भी चले जाएंगे, लेकिन ये मुल्क यहाँ पे रहेगा। और जिसने भी इसमें जो कंट्रीब्यूशन की है, कुछ गलतियां भी की होगी, अच्छाइयां भी की होगी, तो हादसा था, गुजर गया होगा, किसके जाने की बात करते हो? सारी दुनिया के रंजो गम देकर हमारी अवाम को यही दिया जा रहा है ना, रंजो गम उनको दिए जा रहे हैं। कोई उनका ऐसा लगता है जैसे कोई भारी वालिस नहीं है। सारी दुनिया के गम, रंजो गम देकर मुस्कुराने की बात करते हो, फिर हमें कहते हो कि आप मुस्कुराओ भी। अच्छे तरह का एक एक्सटर्नल जो गेटअप है, सही सलामत रहो, मुस्कुराओ, अब खड़े हो, सारी दुनिया के रंजो गम देकर मुस्कुराने की बात करते हो। बहरहाल मुझे याद आया आपकी बात सुन के, जावेद कुरैशी साहब की डेथ हो गई थी 1994 में मेरा ख्याल। अभी मैं आपसे कुछ बातचीत करना चाह रहा हूँ, उम्मीद है कि बिल्कुल आएगी। एक अनाउंसमेंट मैंने आपको कर दी है, हम यौम तकबीर बनाना चाह रहे हैं, और कुछ अथॉरिटीज ने मुझे डिस्कस किया कि आप मिला करें, मगर इसके बावजूद हम करें, क्योंकि हमने एक इंडिपेंडेंट चला है और अब ये रिस्पेक्ट है उन लोगों की जिन्होंने पाकिस्तान के लिए कुर्बानियां दी और आज इस दुनिया में गई है। जो काम उन्होंने किया और उनकी टीम ने की, उनमें अब कुछ लोग हैं, कुछ लोग दुनिया में नहीं है, कुछ लोग हैं, उनमें कुछ लोग जेलों में हैं, मॉन्ट्रियल में, न्यूयॉर्क में जेलों में 25-25 साल की कैद। उनका क्या कसूर है? उनका ये कसूर है कि उन्होंने ऐसा इक्विपमेंट यहाँ से लिया, यहाँ से लिया, वहां से लिया, पाकिस्तान को शिप किया और वो इक्विपमेंट यहाँ लगा और ये न्यूक्लियर एसेट जो हमने बताया, ये ऐसे नहीं किया हुआ, तो हम उसको याद करना चाहिए। एक तो डॉक्टर शौकत विरक साहब है, जो कि चीफ एग्जीक्यूटिव इस वक्त ऑफिसर है डॉक्टर ए.क्यू. खान ट्रस्ट के, और एक डॉक्टर नजीर अहमद साहब है, जो चीफ इंजीनियर मेटलर्जी के थे उस जमाने में, जब डॉक्टर ए.क्यू. खान साहब काम करते थे, उनके साथ काम करते थे। तो मैंने उनको बुलाया 28 तारीख की सुबह की आफ्टरनून, 28 की आफ्टरनून में वी विल स्पेंड सम टाइम टुगेदर। तो ये दो जो जो साथी थे डॉक्टर ए.के. खान साहब के, वैसे तो इन वे मैं भी साथी हूँ, क्योंकि मैंने भी उनके साथ फेस टू फेस काम किया है और मुझे उनकी बातें याद है। और इंशाल्लाह 28 को मैं उनकी याददाश्त जो है वो दोबारा से उसको दोहराऊंगा कि वो क्या शख्सियत थे और कैसे वो काम करते थे, कैसे चलते थे। तो उनके नाम पर हमने एक गोल्ड मेडल भी इंस्टीट्यूट किया था। 50 लोगों को हमने गोल्ड मेडल्स दिए पाकिस्तान में, जिन्होंने इंजीनियर्स दिए सारे पाकिस्तान में इंजीनियरिंग में जिसने बहुत अच्छे बड़े बड़े काम किए, हमने उनको गोल्ड मेडल्स दिए थे। डॉक्टर ए.के. खान गोल्ड मेडल। तो बहरहाल कमिंग बैक टू हियर, आज का जो सेशन है ये उन यंग पार्टिसिपेंट्स के लिए कुछ लाइट का मसला हुआ, क्योंकि ये जो बिखरे हुए लोग हैं, कुछ लाइट का यहाँ भी मसला है, कुछ उनके यहाँ भी लाइट का मसला है। एनीवे, इनको हम बिल्डअप करना चाह रहे हैं। जैसे शाइला सुफान ने कहा, एंटरप्रेन्योर बनाना चाह रहे हैं। एग्जैक्टली एंटरप्रेन्योर का लफ्ज तो बड़ा सा अजीब सा हो गया, बड़ा काफी देर से ये काउंट किया जा रहा है, मगर वो होता क्या है वी डोंट नो। बहरहाल जो है वो है, जो नहीं है वो नहीं है। जैसे वो कहते हैं ना, या तो आप आर्टिस्ट है या आर्टिस्ट नहीं है, या पेंटर है या पेंटर नहीं है। इसी तरह या तो आप एंटरप्रेन्योर है या नहीं है। सो वो एंटरप्रेन्योर कौन होता है, उसकी क्वालिटीज क्या है। आपने अगर कुछ थोड़ा बहुत अगर आपने उस तरफ आना है, तो आपको अपनी शख्सियत में क्या रंग ढंग लेना है, क्या रूप चढ़ाना है। तो मैं आज की इसमें जाऊंगा, इसको सॉल्यूशन प्रोवाइडर में कहता हूँ, एंटरप्रेन्योर की बजाय इंजीनियर्स का जहाँ तक लफ्ज आता है, तो आई लाइक टू कॉल देम सॉल्यूशन प्रोवाइडर्स, जो कम्युनिटी को और इसको इंडस्ट्री को सॉल्यूशन प्रोवाइड करे और उनका भी फायदा करे, अपना भी फायदा करे। दे वर्क लाइक बिजनेस लाइक मैनर, feed themselves and do good to others as well. So ये solution providers है, you can call them entrepreneurs. उनका टारगेट होना चाहिए, थोड़ा सा यहाँ फर्क है। जो कन्वेंशनल एंटरप्रेन्योर है वो तो अपनी जेबें भरता है। कन्वेंशनल एंटरप्रेन्योर जो है ना, आपने इंटरेक्ट किया होगा बिजनेसमैन के लिए। टिपिकल बिजनेसमैन जो है वो आपको 1 मिनट नहीं देगा जब तक कि उसका अपना फायदा उसमें नहीं होगा। तो मैं काफी ऐसे लोगों से वास्ता मेरा पड़ चुका है। एनीवे, ये जो काइंड ऑफ एंटरप्रेन्योर जो मेरी नजर में है, ये जरा थोड़ा सा बखरी टाइप का है। It's like they need to serve the needs of the people or the customers or community. कस्टमर का लफ्ज भी काउंट होता है, बड़ा अच्छा लफ्ज नहीं है, कॉलेज पीपल इज कस्टमर्स। तो बहरहाल एक कस्टमर्स नहीं है, ये आपके लोग हैं जो कि जरूरतमंद है, नीडी है, और नीड्स आर देयर। कुछ लोगों को अपनी नीड्स का अंदाजा भी नहीं है। इसी तरह हमारी जो स्मॉल इंडस्ट्रीज है, अब आप अगर आपकी गाड़ी का टायर पंक्चर हो जाए तो आप पंक्चर लगवाते हैं, कोई एक चीज आपने वॉच की है वहां पर क्या होता है। आज का जो पंक्चर लगाने वाला है वो फुली इक्विप्ड है, वो पहले हथौड़े मार मार के तो टायर को तो व्हील में से निकालते थे, ट्यूब बीच में से निकालते थे, अब वो नहीं करता। उसके पास पंप है, हाइड्रोलिक एक्शन है और वो टायर अलग हो जाता है। फिर उसके पास गैजेट्स है, प्रेशर मेजर करता है। सो ही इज इक्विप्ड विद टेक्नोलॉजी। लेकिन when you go into small industries, micro industries, ये वेल्डर है, ये कूलर बनाने वाले, ये छोटी छोटी चीजें बनाने वाले लोग, ये they are not equipped, they are not equipped with जिसकी बातें हम आज कर रहे हैं, जिसकी बातें डॉक्टर साहब ने बताई है। अब are these things out of reach? They are not. यही हम उनको बताना चाह रहे हैं कि ये रोबोटिक्स जो है आपकी विद इन रीच है, और ये विद इन रीच बताने के लिए we need a group of people। ये जो पार्टिसिपेंट्स हैं, जो अब तादाद उनकी कम होती जा रही है, anyway, मैं तो बोलते जाऊंगा तादाद एक भी होगी, उनको भी मैं बोलूंगा। We started with about 70-80, तो कुछ लोग उनके पास बिजली नहीं है, कुछ लोग ने इंटरेस्ट लूज कर दिया है, whatever they are. So now I want to focus कि जिनको आप सर्विस देना चाह रहे हैं, उनकी पहले नीड्स को देखें कि क्या है। अगर आपने उनकी नीड्स को, रियल नीड्स को टच कर दिया, संभाल लिया, आइडेंटिफाई कर लिया, तो आपने उनको विन कर लिया। दिस इज द क्रुक्स ऑफ द मैटर। ये सारा जो आपका जो नौजवान है ना, आज का जो इंजीनियर है, जिसको हम चाह रहे हैं कि वो सर्विस प्रोवाइडर हो, सॉल्यूशन प्रोवाइडर हो, उसका जो फोकल पॉइंट है वो ये है कि वो कस्टमर की नीड को पहचाने। कस्टमर का लफ्ज अच्छा नहीं, कुछ और कह ले, जरा बाइज्जत तरीका भी होना चाहिए। पीपल नीड यू। अच्छा, इसको उठाते जाए ना। Engineers, I want to tell the engineers that people need you. Maybe ये मैसेज अभी तरह कन्वे हुआ नहीं है। Engineers इस कॉन्सेप्ट में नहीं है, इस माइंडसेट में नहीं है that there are people who need that. Engineers इस माइंडसेट में अभी नहीं है, मगर मैं उनको झंझोड़ के कहना चाह रहा हूँ कि आप लोग आटे में नमक के बराबर है। कितनी परसेंटेज है आपकी पॉपुलेशन? 22 करोड़ अवाम में इंजीनियर्स, जो ग्रेजुएट इंजीनियर्स हैं, उनकी क्या रेशियो है? हॉरिबली लो, हॉरिबली लो। अगर आप अदर कंट्रीज का मुकाबला करें तो हमारी जो इंजीनियर्स की जो रेशियो है, इसमें पाकिस्तान इंजीनियरिंग काउंसिल में जो रजिस्टर्ड इंजीनियर्स है, इनकी तादाद 200,000 के लगभग। दैट्स ऑल। 22 करोड़ के मुकाबले में 200,000 की फिगर जो है वो क्या रेशियो है? नथिंग। अगर आप इंजीनियर्स बन गए हैं, maybe you from your own efforts or from somebody else's resources, you are a lucky man. अब आपको जिसने बनाया है इंजीनियर, आपने कुछ पे बैक करना है। You have to pay back to the society, to the community. अगर आपके इर्द गिर्द सड़कें टूटी रहेगी, पानी नहीं मिलेगा, हाइजीनिक कंडीशन नहीं होगी, सीवरेज नहीं होगा, बिजली की शॉर्टेज होगी, तो आप अपना जो ड्यूटी है वो पूरी नहीं कर रहे। इररिस्पेक्टिव कि गवर्नमेंट क्या है, सियासी हालात क्या है, एक इंजीनियर को डायरेक्ट अपनी कम्युनिटी के साथ राब्ता है। ही इज आंसरेबल टू हिज ओन कम्युनिटी। वो जहां पर वो पैदा हुआ, वो मोहल्ला जहां पे वो बड़ा बड़ा, वो माँ बाप जिसने उनको पाला पोसा, वो माहौल, you are answerable to them. तो अब ये रियलाइजेशन इंजीनियर्स को होनी चाहिए कि आप you are precious and people need you. Be innovative. Innovation भी हम लोगों में बहुत कम है. ये मैं जो बातें कर रहा हूँ ये शुएब साहब की बताई हुई बातें हैं. We had long sessions together. So we have worked together, we have lived together. तो इनोवेशन किसको कहते हैं? इनोवेशन हम इंजीनियर्स ज्यादातर कॉपी करते हैं, कॉपी करने के बाहर है. आज ये प्रोजेक्ट करना है, कोई इस तरह का मिलता जुलता कोई पहले प्रोजेक्ट हुआ है उसको उठाएंगे, उसी का बिलों को इंट्रोड्यूस जो है पकड़ेंगे, उसको आज के रेट्स लगा लूंगे तो अब आगे चलाएंगे. ड्राइंग्स भी कोई ब्रिज पहले बना होगा उसको ले लेंगे, उसी ब्रिज को कॉपी करेंगे. कई साल तक आई डोंट नो, मैं आपको आपकी बातें आपको क्या बताऊं. ये रावी का एक ब्रिज बना था, प्रीस्ट्रेस्ड कंक्रीट ब्रिज. वो डॉक्टर पीटर जो जर्मनी के थे, ल्यूडहॉर्न. पता नहीं आप लोगों की तो ये शायद जनरेशन नहीं है, पहले की बात है. एक प्रीस्ट्रेस्ड कंक्रीट ब्रिज जो लाहौर की रावी के ऊपर बन गया, साल तक उसकी कॉपी होती गई. वही स्पैन्स, वही डेप्थ्स, वही सरिया, वही चीज डिट्टो कॉपी किया. हुकूमत पंजाब हाईवे डिपार्टमेंट डिट्टो कॉपी करते गए साल तक. वही उन्होंने चिचिया वाली बनाया, वही मुल्तान में डाल दिया, वही उधर डाल दिया, वही उधर डाल दिया. कॉपी करते गए. कॉपी क्यों करते हैं? क्योंकि सेफ होता है. मगर अगर आप उसको थोड़ा सा चेंज करना चाहेंगे तो फिर आपको गट्स चाहिए होंगे. फिर आपको उसको वेरीफाई करना है. योर डिजाइन हैज टू बी टेस्टेड, हैज टू बी वेरीफाइड, हैज टू बी पेटेंटेड, हैज टू बी सर्टिफाइड. सो उस नए आइडिया को एक, मैं क्यों सॉल्यूशन प्रोवाइडर की बात कर रहा हूं, क्योंकि प्रॉब्लम आपको नजर आएगी फिर ही आप उसका सॉल्यूशन करेंगे. और अगर आपने सॉल्यूशन किसी और का उठा के कॉपी करके डाल दिया तो वो सॉल्यूशन तो नहीं होगा. सो इनोवेशन का मतलब है समझना पहले कि मसला है क्या, और अगर आप एग्जैक्टली उसको समझ गए उस मसले को तो आप ये समझे कि 50% यू हैव सॉल्व्ड. एग्जैक्ट अंडरस्टैंडिंग ऑफ द सिचुएशन ये सिर्फ इंजीनियरिंग में अप्लाई नहीं होती, तो हमारे लाइफ के हर शोबे में ये चीज अप्लाई होती. तो एग्जैक्टली आप उसको मार्केट एनालिसिस कह लें या आप उसको कुछ भी कह लें, नौयत को समझ लेना और उसके मुताबिक सॉल्यूशन करना. क्योंकि अगर उसके मुताबिक आपने सॉल्यूशन ना किया तो वो सस्टेनेबल नहीं होगा. हमें पता है कि ये सड़क, इस पर इतना ट्रैफिक हो जाएगा, इतने व्हीकल्स होंगे, एनुअली रन करेंगे, पैसेंजर कार यूनिट्स कहते हैं इनको, PCUs. अगर आपने वही फिगर्स किसी और सड़क पे कॉपी करके और वही डिजाइन कर दिया तो फिर आपने कोई सॉल्यूशन तो ना किया. तो ये इनोवेशन से मुराद है एग्जैक्ट अंडरस्टैंडिंग of the problem and finding the right solution of it. इसको आइडिया कहते हैं. और आइडिया की कीमत होती है. अगर आपने अपने क्लाइंट को, कस्टमर को सही, उसकी नीड्स को सही तरह से पहचान लिया, समझ लिया, और आपने उसके मुताबिक डिजाइन सॉल्यूशन दिया है, तो आप कामयाब है, आप इनोवेटिव है और आपका सोल्यूशन जो है वो सस्टेनेबल है। फिर उस आइडिया को लेके आपने प्लान करना है और उसके ऊपर एक्शन करना है, क्योंकि इंजीनियर तो सिर्फ ख्यालात तक तो महदूद नहीं रखता ना अपने आप कि मैं सोचूं और सोचो में गुम रहो और करूं कुछ ना। ऐसे भी लोग होते हैं, वैसे काफी लोग ऐसे होते हैं जो सिर्फ सोचते हैं, सोचते ही रहते हैं और सोचो में गुम रहते हैं। लेकिन इंजीनियर्स ऐसे नहीं होते। इंजीनियर्स को एक सोच आती है, फिर वो रेस्टलेस होते हैं, यार मैंने इसको अप्लाई करना है, और अप्लाई करने के लिए पहले उसको अपने आइडिया को टेस्ट करना पड़ता है। जो मैंने सोचा है क्या दूसरे आपका साथ देते हैं, लोग क्या सोचते हैं उसके बारे में, फिर वो आइडिया वर्केबल है या नहीं है। सॉल्यूशन प्रोवाइडर, एंटरप्रेन्योर के बजाय मैं इसका नाम सॉल्यूशन प्रोवाइडर कहता हूँ, क्योंकि सॉल्यूशन प्रोवाइडर मैं इसलिए कहता हूँ कि वो दूसरों की नीड्स को समझ रहा है और उसके मुताबिक चल रहा है। एंटरप्रेन्योर तो अपनी जेबें गर्म कर रहा है। A person who meets the direct needs of the customer or people, organizes and maintains activities in a business-like manner. It requires innovative mindset, considerable confidence, initiative, and a convincing power and risk-taking. क्योंकि अगर आपने इनोवेटिव आइडिया पैदा किया, that means कि वो एक मुनफरिद आइडिया है, लोग पहले उस तरह का नहीं सोच रहे या उस तरह की चीजें नहीं बनी हुई, आपकी अनोखी बात है, अनोखी सोच है, तो फिर आपको रिस्क भी लेना है। फिर आपके अंदर इतनी कन्विंसिंग पावर होनी चाहिए कि कोई आपके आइडिया के ऊपर पैसा भी लगा सके, कोई आपके आइडिया को मान भी सके। सो ये जो प्रोसेस है, आइडिया फॉर्मेशन, कॉन्फिडेंस बिल्डिंग, कन्विंसिंग पावर, इसकी बातें आज हम थोड़ा सी चंद मिनटों में हम करेंगे। तो जिन लोगों की नीड्स हम सर्व कर रहे हैं वो आपके कस्टमर्स हैं। सो ये कस्टमर की डेफिनेशन थोड़ी सी फर्क है। वो दुकानदार के पास तो जो आता है बंदा वो उसका कस्टमर है। ये हमारी जो कस्टमर है, हमने फोकस किया है एक इंडस्ट्री के ऊपर, हमने फोकस किया है कम्युनिटी के ऊपर। हमने उस इंडस्ट्री, उस कम्युनिटी की एग्जैक्ट नीड्स को जांचा और उसको सॉल्यूशन प्रोवाइड किया। यही काम हुआ अमेरिकन अर्बन लैंडस्केप जब डेवलप हो रहा था। मैं भी बहुत से लोगों को हमें पता नहीं है इस चीज का। यहाँ भी बहुत से यूनिवर्सिटीज में से अर्बन प्लानर्स निकलते हैं, लैंडस्केप आर्किटेक्ट्स निकलते हैं। कितने हैं अर्बन प्लानर्स जो कि चौक में खड़े होकर कहते हैं कि सड़क को ऐसे नहीं होना चाहिए, इसको ऐसे होना चाहिए। कुछ भी नहीं। मगर अमेरिकन सिटीज ऐसे डेवलप नहीं हुए। अमेरिकन यूनिवर्सिटीज में से जो निकले हैं ना एनवायरमेंटलिस्ट, अर्बन प्लानर्स, they were kind of volunteers, privateers. अमेरिका तो गढ़ है प्राइवेटियर्स का। जो हम में से कुछ लोग जो अमेरिका में रहे काम कर रहे हैं, they know कि अमेरिका लैंड ऑफ अपॉर्चुनिटी कहलाते थे ना। क्यों? क्योंकि वो लैंड है प्राइवेटियर्स। तो ये वो लोग थे। अब आप लेफ्ट हैंड साइड पे देखें, अमेरिकन सिटीज इन द 20s, 1920 में अमेरिकन सिटीज ऐसे ही लगता है जैसे ये कोई शालवी या रंगमहल का कोई सीन है। ऐसा ही सीन था वहां भी। अमेरिका में एग्जैक्टली यही था हालात। दूर से नजर आ रहा है। अब बीच वाली शक्ल देखिए, ये कुछ यंग बॉयज एंड यंग गर्ल्स हैं जो कि कुदाली लेके सारा ये गंद सारा साफ कर रहे हैं। They were volunteers, urban landscape architects, urban planners. They came forward, young engineers, fresh graduates from the universities. और वो सड़कों पे गए और उन्होंने कहा कि हमने इसको ऐसे डेवलप करना है। उन्होंने प्ले कार्ड्स लगाए, पोस्टर्स लगाए। हमारे यहाँ जो जुलूस निकलते हैं उनके जो प्ले कार्ड्स होते हैं वो डिस्ट्रक्टिव होते हैं, वो तो किसी ना किसी को टारगेट किया होता है, किसी के मुखालफत में होते हैं, और वो चीरा झपटी वाले पोस्टर्स हैं। जब ऑरेंज लाइन बन रही थी तो टारगेट्स थे मत बनाओ मत बनाओ मत बनाओ, एनवायरनमेंट खराब हो रही है, वाइब्रेशन हो रही है, धुआं निकल रहा है। कहाँ है धुआं, कहाँ वाइब्रेशन? वो ट्रेन आके गुजर जाती है उसकी आवाज भी नहीं आती। तो ये प्राइवेट ईयर्स, यंग ग्रेजुएट्स अमेरिकन यूनिवर्सिटीज के बाहर निकले हुए, दे हैड द गट्स। उन्होंने पोस्टर्स लगा दिए, ये शहर हमें ऐसा नहीं चाहिए, हमें इसको बेहतर बनाना है। जब उन्होंने जैसे ये किया, जो इस डेवलपमेंट में, हाँ जी शबीर साहब आ जाओ सर आ जाओ, तो याद करते रहते। जब उन्होंने ऐसी आवाज उठाई, ये रियल फैक्ट्स है, मैं आपको बता रहा हूं, तो लोग चुकन्ने हो गए। वो कहते जी गवर्नमेंट किस लिए है, उसको स्पेंड करना चाहिए। मगर उस वक्त की गवर्नमेंट भी ऐसी ही थी जैसी कि आज की गवर्नमेंट यहाँ पाकिस्तान की। एग्जैक्टली ये सिनेरियो रिपीट हो चुका हुआ है। वो लोग गुजर चुके हैं इस सिनेरियो से। यदि गवर्नमेंट ने कुछ नहीं करना, फिर किसने करना है? वो तो नहीं करना है जो कि इफेक्टिव है, जो जिसका बिजनेस खराब हो रहा है, जो इफेक्टिव है, जिनका बिजनेस खराब है, वो ये चाहेंगे कि हमारे जो कस्टमर्स हैं उनकी गाड़ियां भी आके खड़ी हो सके, पार्किंग भी उसकी हो सके, वो हमारी दुकान तक पहुंच भी सके, तो वो खर्च करेंगे। And they did. और आज दाएं तरफ अगर आप देखें, आज का जो मैनहट्टन है वो आपको ऐसा नजर आता है। ये जो स्ट्रक्चरल चेंज पैदा किया अमेरिकन सिटीस्केप के ऊपर, ये प्राइवेटियर्स ने पैदा किया। अब मैं भी ये चाह रहा हूं कि हमारे जो सिविल इंजीनियर्स हैं, हमारे जो प्लानर्स हैं, वो भी आए, emerge as entrepreneurs, emerge as solution providers। किसी ने नहीं आना, आपके हालात को तब्दील किसी ने नहीं करना, इंजीनियर्स ने करना। और इसके लिए डायरेक्ट एक्शन की जरूरत है। अच्छा, पहले जमाना, अब जमाना चेंज हो गया। पहले ये कोई बात करता था तो वो महदूद रहती थी, वो डब्बे में किसी में बंद हो जाती थी। अब आज अगर आप बात करते हैं तो वो महदूद नहीं होती, क्योंकि आपके पास टेक्नोलॉजी इंस्ट्रूमेंट्स है। आज का जो सोशल मीडिया इतना स्ट्रॉन्ग है, द वर्ल्ड गोज अराउंड एवरीवेयर। ये जो मोबाइल है, इस पर आप तमाम स्टेक होल्डर्स लोकेट भी कर सकते हैं, उन तक पहुंच भी सकते हैं, उनका डेटा हासिल कर सकते हैं, उनके मोबाइल नंबर्स हासिल कर सकते हैं, उनके ईमेल्स हासिल कर सकते हैं। All you need is to discover that। अगर आपको कोई इशू किसी जगह पर नजर आता है तो उसको बीट विद करने वाले लोग आपको मिल जाएंगे, जो कि आपको पैसा भी लगाएंगे। अगर प्रोवाइडेड योर आइडिया शुड कैरी वेट, प्रैक्टिकल भी होना चाहिए, सस्टेनेबल भी होना चाहिए, तो कैपिटल अट्रैक्ट होगा। फिर एक और कंडीशन इसकी ये है कि आपके हाथ में टेक्नोलॉजी होनी चाहिए। जो कि अक्सर नहीं है, क्योंकि इंजीनियर्स का माइंडसेट ही उस तरफ नहीं गया था। इंजीनियर्स ने तो कहा कि कोई वर्ल्ड बैंक का काम हो, एशियन डेवलपमेंट बैंक का प्रोजेक्ट हो, हमें अच्छी तनख्वाहें मिले, हम एयर कंडीशन माहौल में बैठे, व्हाइट कॉलर हो, रोब शोब हो हमारा, इर्द गिर्द लोग जो है ना हमारे सुपरवाइजर्स और सर्वेयर्स और बिल्डिंग इंस्पेक्टर्स वो घूमे और हमारा रोब हो, हम आके गाड़ी खड़ी करें तो कोई दरवाजा खोलने वाला हो। तो हमने ये नहीं सोचा कि ये इज्जत जो आपको मिल रही है इसकी आपने रिटर्न भी आप करना है। अब अगर आपने अपने आप को चेंज करना है और आपने एज ए सोल्यूशन प्रोवाइडर अपने आप को बिल्ड करना है, एज एन एंटरप्रेन्योर अपने आप को बिल्ड करना है, आपका अपना एक आपकी हैसियत हो कि आप कम्युनिटी में जाए, इंडस्ट्री में जाए और लोग आपको हाथों हाथ ले और कहे जी आओ हमारे मसले हल करो। फिर आपको क्या क्या अपने स्टेप्स क्या है, ये बात क्या है। एक तो ये आप देख रहे हैं तस्वीरें बना के बाजी की जा रही। तो लो स्टार्टअप कैपिटल, अगर आपने एंटरप्रेन्योर बनना है, आपने बिजनेस करना है, मेक श्योर लो स्टार्टअप कैपिटल से स्टार्ट करें जो आपकी हैसियत के मुताबिक हो। और लंबे हाथ मारेंगे तो आप गिरेंगे, जितनी ऊंची छलांग मारेंगे उतनी जल्दी आप गिर जाएंगे। सो इसलिए स्टार्टअप कैपिटल जो है ना वो लो होना चाहिए, एक पॉइंट। सेकेंडली आपकी जो यूजफुलनेस जो है ना लोगों की, वो इजी होनी चाहिए, इजी टू सेल। आपकी जो बात है वो दूसरों को समझ बहुत आसानी से आ जानी चाहिए। It should go straight into their hearts। जो आप बात करें वो दूसरों को समझ आनी चाहिए। फिर तीसरा पॉइंट है कि विदिन योर कोर कॉम्पिटेंस, जिसके लिए आपको ट्रेन किया गया है, जो शोभा है आपका, जो कि आपकी स्ट्रेंथ पॉइंट है, उसी में रहकर आप काम करें। अगर आप उससे बाहर जाके करेंगे काम तो फिर मे बी मोर रिस्की। ये जो है ना पर्सनल कैरेक्टरिस्टिक्स चाहिए, कुछ खास कैरेक्टरिस्टिक्स है जो अगर आप अपने आप को सॉल्यूशन प्रोवाइडर के तौर पर, अपने आप को एंटरप्रेन्योर के तौर पर बिल्ड करना चाह रहे हैं, तो कुछ आपको नेट प्रैक्टिस भी करनी है। कुछ कैरेक्टरिस्टिक्स ऐसे हैं जो कि आपको अपने अंदर रिक्वायर करने हैं। कुछ लोगों ने कर लिए होते, वो बचपन से कर लिए होते, स्कूल टाइम में भी किए होते। कुछ आपके बच्चे जो है वो बड़े होशियार है, आपसे पैसा ईटने में बड़े होशियार है, बड़ी बिल्डअप स्टोरीज करके तो आपसे जेब खर्च लेके चले जाएंगे। ये उनकी ट्रेनिंग ग्राउंड है एक्चुअली। दे आर लर्निंग हाउ टू एक्सट्रैक्ट मनी फ्रॉम अदर्स। ठीक है, ये भी एक क्वालिटी है, पर्सनल कैरेक्टरिस्टिक्स है। हर कोई तो नहीं किसी की जेब में से पैसे निकाल सकता। फिर रिस्क लेने का मजा जो है, कुछ रिस्क टेकर्स है, कुछ रिस्क टेकर्स नहीं होते। आपको टू एन एक्सटेंट रिस्क लेना सीखना चाहिए। अगर आपने बचपन में सीख लिया तो बहुत अच्छा। कई बच्चे आपने देखे बड़े रिस्क लेते हैं, वो उसके ऊपर पैरापेट पे खड़े हो गए बिल्डिंग के, उसको बचाते हुए गिर जाओगे, वो खड़े हो गए, उनको अच्छा लगता है। सो एक रिस्क टेकिंग बैक अपने आप में आपको बिल्ड करना है कि जी की हो जाएगा, मेरी बेइज्जती कर देगा, फिर क्या हो गया। मुझे कुछ माली नुकसान हो जाएगा, क्या हो गया? सो रिस्क लेने का हौसला आपको बिल्ड करना है अपने आप में। फिर ये सोशल स्किल्स है। सोशल स्किल्स अनफॉर्चुनेटली इंजीनियर्स में इतनी ज्यादा नहीं होती। क्यों नहीं होती? वो जो 4 साल धक्का खाया होता है ना, इंजीनियरिंग के जो कोर्स सब्जेक्ट्स आपने किए होते हैं, मैथमेटिक्स बहुत ज्यादा पढ़ा होता है, वो जो पार्शियल डिफरेंशियल इक्वेशंस आप पढ़ते हैं ना, फिर सोशल स्किल्स खत्म हो जाती है। देन यू आर काइंड ऑफ ए रोबोट योरसेल्फ। किसी से बात नहीं करना चाहते आप। आपने देखा होगा कुछ बच्चे ऐसे होते हैं, हम खुद भी कुछ ऐसे हैं, मैं भी कुछ ऐसा था यंग टाइम में। बात करना तो फजूल लगता है, क्यों मैं बात करूं उससे? बैठ के काम करना अच्छा लगता है। मगर सोशल स्किल्स अगर आप में नहीं है तो आप अच्छे बिजनेसमैन नहीं बन सकते। अगर सोशल स्किल्स आप में नहीं है तो आप अच्छे सेलर नहीं बन सकते। आपने आइडिया सेल करना है ना। अब सोशल स्किल्स कैसे आप डेवलप करें? अगर अनफॉर्चुनेटली डेवलप नहीं हुई, आप ज्यादातर साइंस पढ़ते रहे, आपने मुशायरे अटेंड नहीं किए, या आपने क्रिकेट नहीं खेला, या आपने गपशप नहीं मारी, तो फिर आप अपने सोशल स्किल्स पर। फिर एक और जो नीचे है खास, ये फ्लेक्सिबिलिटी, जो कि हमें नहीं होती। जितनी उम्र ज्यादा बढ़ती जाती है ना, फ्लेक्सिबिलिटी कम होती है। अगर आप अपने आप को कुछ समझने लगते हैं तो इसका मतलब फ्लेक्सिबिलिटी कम होती है। The moment you think that you are a wise man, you no longer become a wise man. You lose all that wisdom. So acceptability to ideas, एक फ्लेक्सिबिलिटी है। लोगों की बात सुनना समझना, वो क्या कह रहा है, फ्लेक्सिबिलिटी है। फिर एक और जो पर्सनल कैरेक्टरिस्टिक्स है यहाँ पर, वो लीडरशिप है। कुछ लोगों में ये क्वालिटी है, कुछ लोगों में क्वालिटी नहीं है। कुछ लोगों में ये क्वालिटी है, बड़ी कहानी आपको सुनाएंगे और आप समझेंगे इससे अच्छा तो बता ही कोई नहीं। तो इसका मतलब आपने अपने आप को लीडर एस्टेब्लिश कर लिया। मैं उस वक्त तक बोलते जाऊंगा जब तक कि लंच नहीं आता। जल्दी आ जाएगा। हाँ, अभी 10 मिनट में आना चाहिए। ये पर्सनल कैरेक्टरिस्टिक्स है, आप ने अपने सामने रखने हैं और बिल्ड करने। एक्शन मैन, you need to be a kind of a Spider-Man yourself. कि कोई एक सिनेरियो आता है सामने आपके, तो आपको जंप करना, टाइम वेस्ट नहीं करना। अगर बस आके रुकी है तो आपने उसमें चढ़ जाना, ना कि आपने सोचना है कि इसमें मैं चढ़ूं या ना चढ़ूं, बस चलिए। ऐसे होता है। आप किसी और की बात करें, मैंने कहा मेरी बात पे आते हैं। अच्छा, खाने का राइट। अच्छा, एक्शन मैन अगर किसी ने तो नहीं आपको बनाना, आपने खुद ही बनना। सो अभी भी टाइम है, सुबह सुबह उठ के एक्सरसाइजेस करें, एक्शन मैन बन के दिखाएं। आपकी फैमिली वाले परेशान हो जाएंगे, वैसे क्या हो गया आपको? क्या हो गया? एक्शन शुरू कर दिए। आर्ट ऑफ सेलिंग एंड आर्ट ऑफ हीलिंग, ये आपस में कनेक्टेड है, बोथ टुगेदर। सेलर वही है जो अच्छा हीलर है, क्योंकि हर शख्स परेशानियों में मुब्तला है। और अगर आप बात ऐसी करें जो कि दूसरे को थोड़ी सी कंसोलेशन उसमें मिले तो आपने उस मुद्दे को विन कर लिया। कुछ लोगों की बातें ऐसी होती है, कुछ लोगों की बातें ऐसी नहीं होती। कुछ लोगों की बातें ऐसी होती है, आप उनके साथ 15 मिनट गुजारते हैं, आधा घंटा गुजारते हैं, बाहर आते हैं तो आप कहते हैं यार वक्त ही जाएगा, इत्थों तो मैंने कुछ नहीं लगता। फिर एक और जो पर्सनल कैरेक्टरिस्टिक्स है, आपको अपने अंदर सुपर ईगो चाहिए। सुपर ईगो चाहिए, चैलेंजेस को फैलाने की जो अर्ज है वो आपको चाहिए। ये दीवार है, ये क्यों दीवार है? या तो मैं इसको गिराऊंगा या मैं उसके ऊपर से फैला दूंगा। अगर आप में ये स्किल्स है, आप में ये बेंट ऑफ माइंड है, आप अच्छे एंटरप्रेन्योर हैं। अगर आप में ये बेंट ऑफ माइंड नहीं है तो बिल्ड कर सकते हैं आप, कोई मना तो नहीं करता। वही बात है दूसरी वाली, ये भी इनडोमिटेबल स्पिरिट कुछ लोगों में होती है, इनडोमिटेबल स्पिरिट। बुरे लफ्जों में कोई उनको टेट भी कहते हैं, यार बड़ा टेट इंसान, इनडोमिटेबल। उसके माइंड में आ गया, उसमें से वो फिर नहीं निकलता, उसने हासिल करके रहना। अच्छा जी, अब एक और ये चैप्टर है कि पैसा कहाँ से आता है। जी जी श्योर, Q&A क्वेश्चंस क्या है, तो मैं इसको जल्दी से पारक करता हूँ क्योंकि मुझे पता नहीं आप जो कर रहे थे टेलीफोन क्या। मेरा क्वेश्चन है कि लंच आ रहा है। अच्छा जी, कहाँ से पैसा कहाँ से आना है? आपने अगर बिजनेस शुरू करना है, ये उन लोगों के लिए भी है जो कि पार्टिसिपेंट्स की तादाद कम होती जा रही है। वी स्टार्टेड विद अबाउट 70 to 80, अब ये 48 है, 50 तक तो है। चलो, मगर ये कहाँ कहाँ है, आप इधर अंदाजा लगाए कि ये कहाँ कहाँ पे स्प्रेड ओवर है। कहाँ से पैसा आएगा? आपने कोई काम शुरू करना है, पैसा कहाँ से आएगा? सबसे बड़ा जो पैसे का सोर्स है वो आपकी पर्सनल इक्विटी है, आपकी सेविंग है, आपकी प्लॉट है, आपके पास है, आपकी प्रॉपर्टी है, वो रख छोड़ेगी, बच्चों के काम आएगी, या कोई जाली रजिस्ट्री बना के तो आपको उपाय हो जाएगा। वो कब काम आएगी? आपकी जो प्रॉपर्टी है वो कब काम आएगा? बैंक का बैलेंस है, जबकि आपको आज पैसे की जरूरत है। तो इसलिए आप उसको मोबिलाइज करें, उसके फिक्स्ड एसेट्स को लिक्विड एसेट्स में कन्वर्ट करें और उसको इस्तेमाल करें। ये वक्त है। क्यों शुएब साहब, जाके रजिस्ट्रियां करा के ना पैसा इकट्ठा कर लो। फैमिली सपोर्ट सेकंड सोर्स जो है ना आपका, वो फैमिली सपोर्ट है। अपने बाप से मांग ले, फादर से मांग ले। इसके लिए भी आपको चाहिए एक फूल्स। फूल्स कुछ फूल्स हैं जो दे देते हैं। इससे पहले ये था इन्वेस्टर्स। इन्वेस्टर्स भी आ जाते हैं। इन्वेस्टर्स आपके काम में, आपके कारोबार में इन्वेस्ट कर रहे हैं। उनका अपना क्राइटेरिया है, वो देखते हैं कि मेरा पैसा अगर यहाँ मल्टीप्लाई हो रहा है तो फिर आ जाएंगे, आपको देंगे और देखेंगे कि कहीं लेके भाग तो नहीं जाएगा। परसेंटेज देखेंगे 25-30% जा रहे हैं आजकल। लोन फ्रॉम बैंक्स और एनजीओस, ये भी एक सोर्स है। पब्लिक शेयर्स, जब आप एक लेवल पे चले जाए तो आप शेयर्स फ्लोट करते हैं, फिर आप पब्लिक लिमिटेड कंपनी फ्लोट करें। तो वो पब्लिक आपके काम में पैसा डालने शुरू हो जाएगी, शेयर होल्डर्स हो गए, जबकि आपने अपनी परफॉर्मेंस शो की है। पब्लिक में आपको परफॉर्मेंस शो करेंगे तो आपके स्टॉक जो होगी उसकी वैल्यू बढ़ती है। अगर परफॉर्मेंस आपकी पुअर होगी तो आपके स्टॉक की वैल्यू जो होगी कम होती है, ज़ाहिर है। फिर आप पार्टनर्स इकट्ठे करें, तो खुद अकेला काम इतना नहीं कर सकता, तो आप पार्टनर्स भी आ सकते। सप्लायर्स क्रेडिट ले, आपने जहां जहां से सप्लाईज ले ली है उनके साथ एग्रीमेंट कर ले कि वो आपको क्रेडिट पे देगा चीजें। परचेज ऑर्डर दे, एडवांस परचेज ऑर्डर्स भी एक सोर्स ऑफ है फाइनेंस। इफ दिस चाइल्ड कैन डू इट, सो यू कैन एज वेल डू इट। ये जरा मोटिवेट करने के लिए बनाया गया है। तो अपनी लोकेलिटी में जाए, इश्यूज को आइडेंटिफाई करें, क्या इश्यूज है उस लोकेलिटी में। ट्रैफिक का मसला है, पानी का मसला है, सैनिटेशन का मसला है, कमर्शियल डेवलपमेंट का मसला है। टेक ए ट्रिप अराउंड द एरिया, रिकॉग्नाइज जिसको कहते हैं, इंजीनियर्स के वर्ड में रिकॉग्नाइज, assessment of the need of that area, walk through the area, या खुद करें या किसी को एंगेज करें। उस एरिया में जब आप सर्वे कर रहे हैं तो आप लोकेट कर रहे हैं कि इश्यूज क्या है, और उस इश्यूज को सॉल्व करने में कौन आपके साथ चलने को तैयार होगा, कौन आपका साथ देगा, कौन आपका साथ नहीं देगा। जब आप आइडेंटिफाई, इसको स्टेक होल्डर्स कहते हैं। अगर आपने कोई काम करना है और आपने आइडेंटिफाई किया कि आपका साथ देने वाले कौन है, तो वो स्टेक होल्डर्स हैं। अब वो स्टेक होल्डर्स की कितनी किस्में हैं, कितना उनका इंटरेस्ट इसमें होता है, वो भी मैं आपको बता सकता हूँ। फिर आपने उनके लिए एक प्रपोजल तैयार करना है और रियली उनको कन्विंस करना है। उसके लिए ये टेम्पलेट्स बनी हुई है, ये 3 टेम्पलेट्स हैं। ये मेरा ख्याल शेयर कर ले सबके साथ, ये आप इसको लेके चलेंगे, हमने अटैच कर यूट्यूब में चले जाएंगे। पिछली दफा हमारे पास नहीं अभी क्वेश्चन आंसर हो रहा है, सिर्फ एक झलकी दिखा दे आप क्या है। अच्छा जी, झलकी आ गई है। सो लास्ट टाइम हमने तकरीबन 60 इंटर्नीज को इंटर्नशिप यहाँ पे दी थी आईपी में, जो यूनिवर्सिटी यूईटी से आए थे, नस से आए थे, पास से आए थे। और उन्होंने कहा कि जी समर वेकेशन है, हमने तो अपने अपने घरों को जाना है, तो आप हमें यहाँ पे बिठा रहे हैं। तो हमने उनके घर पर उनको असाइनमेंट्स दी कि अपने अपने को लिया से आया हुआ है, कोई फैसलाबाद से आया हुआ है, कहाँ पे आया हुआ है, अपने घर जाए, वहां बैठ के ये असाइनमेंट करे, अपने एरिया को लोकेट करे, वॉक अराउंड योर टाउन, टॉक टू पीपल, इश्यूज हाईलाइट करे, जो इंजीनियरिंग सॉल्यूशंस है बोले। और इतनी खूबसूरत लास्ट ईयर आपकी हमारी जो इंटर्निस थे, इतनी खूबसूरत प्रेजेंटेशन उन्होंने बनाई, मैं खुद हैरान हो गया कि इन टेम्पलेट्स के ऊपर पहुंचते हुए। और इसका वो जो प्रोफेसर विलियम केले है, उसने बहुत एक्नॉलेज किया कि ये आपने तो, आपकी इंटर्निस ने बहुत काम किया। तो मैं इस दफा भी आ रहे हैं, तो इस दफा भी इंशाल्लाह ये काम हम करेंगे। मेरा ख्याल मैं अब इसको स्टॉप करता हूँ, आप जरा आ जाए और आप माइक को पकड़ लें। तो क्वेश्चन आंसर ऐसे तो रोटी नहीं मिलती, क्वेश्चन आंसर के बाद होते हैं।
हेलो। अभी डॉक्टर साहब ने बात की है इसमें कि अपना फॉरेन जो है इन्वेस्टमेंट, जो लोग फंड चाहिए, तो मेरे पास एक प्रपोजल आई हुई है बहरीन से। ये बहरीन से आई है क्योंकि मैं काफी राब्ता है बाहर। अब तो उन्होंने मुझे कहा कि आपको फिनांस चाहिए, तो नहीं, मैं आपको बता रहा हूँ, उसके आप पहले सुन लें। $1 मिलियन से $600 मिलियन तक उन्होंने ऊपर दी हुई है कैटेगरी के किस किस में हम आगे इन्वेस्टमेंट किए और कर रहे हैं। तो ये इन्वेस्टमेंट है हमारे पास उनकी, ये मेरे पास उनका आई हुई है मेल। तो ये आइडिया के ऊपर ही है फंड, क्योंकि मेरा इस वक्त आइडिया चल रहा है, उनके पास पूरी दुनिया में हेल्थ के ऊपर भी है, इन्वायरमेंट पे भी है, तो इसलिए उनकी तरफ से मुझे आया कि आपको चाहिए फंड। थैंक यू।
नहीं नहीं, बिल्कुल जी, आपने बताया है। तो ये फोरम मेरे नॉलेज में है, और हमने ये जो बूट कैंप आगे इंशाल्लाह करना है, इसमें मतलब प्रोसेस कनेक्शन इस तरह है। करंटली एचईसी ने भी बहुत सारी फंडिंग दी है, दे आर विद द यूनिवर्सिटी, और उनके लिए मस्ट कर दिया गया है कि वो R&D वर्क करें, एंड दे शुड ब्रिंग आउट समथिंग जो कि आगे फिर इंडस्ट्री में यूज हो सके। एक तरफ इंडस्ट्री है, एक तरफ R&D है, और हम लोग हैं बीच में कमर्शलाइज करने के लिए बैठे हैं। तो ये गैप जो था ना, इसको इंशाल्लाह हम कनेक्ट कर रहे हैं। आई एम इन द एडवाइजरी बोर्ड ऑफ 2 डिपार्टमेंट्स ऑफ यूईटी लाहौर राइट नाउ। हमने उस पर सारा होमवर्क कर लिया है। वहाँ के जो इंजीनियर्स हैं वो R&D कर रहे हैं। यदि वो मैंडेटरी है कि आपकी, जैसे आपने रिसर्च की हुई है, आपने उसको कमर्शलाइज कराना है, तो आपको यूनिवर्सिटी की वेटिंग या टैग साथ लगवाना है। सेम वे ये फंड्स आर देयर। इन्होंने अगर वो टाइप्स हमें कोई भी कैटेगरी कही है ना, हम इसको उनके साथ राउट करके इवेंचुअली इंडस्ट्री में ले आएंगे। सो दिस इज गोइंग टू बी समथिंग जो कि हमारे जो पूरा बूट कैंप या साइकिल है ना, कमर्शलाइजेशन का प्रोसेस जो हम लॉन्च कर रहे हैं, उसमें इंशाल्लाह इसमें बहुत काम आएगा। तो लुकिंग फॉरवर्ड टू जी, थैंक यू।
उसकी वजह ये है कि
आवाज नहीं आ रही प्रॉपर्ली। No voice for online participants.
तो इस तरह जो यंगेस्ट लोग हैं जो यूनिवर्सिटी स्पेशली अंडरग्रेड के स्टूडेंट्स या मास्टर्स के स्टूडेंट्स जो है ना उनकी पार्टिसिपेशन जो है ना वो इन लेक्चर्स में बहुत कम है। तो मैं जो है ना इस रेशियो को जो है ना बढ़ाना चाहता हूँ। तो इस सिलसिले में जो है ना ये भी आप लोगों से स्पेशली जो यूनिवर्सिटीज के कंसर्न्ड एचओडीज हैं, डॉक्टर साहबान हैं, उनसे ये रिक्वेस्ट है कि स्टूडेंट्स को बाउंड करें कि वो जो है ना वो लाजमी जो है ना इस तरह की वर्कशॉप्स जो है ना वो अटेंड करें।
बिल्कुल ठीक है यार, सबकी बात बनी आ जाती है, सपोर्ट इज देयर, यूनिटी आ जाएगी।
यूनिवर्सिटी कौन से इस कॉम्प्लेक्स का आंसर ये है, आपको यूनिवर्सिटी आरटी और इन चीजों को बहुत ज्यादा पार्टिसिपेशन कर रहे हैं, इवन डिपार्टमेंट लेवल पे, लोअर लेवल पे, हायर लेवल पे हर जगह हो रही है। ये ऐसी कोई बात नहीं है कि वो नहीं कर रहे हैं। हाँ, अब उनको जो स्पेस और टाइम देना है वो मैनेज करना है। एक्चुअली वो मैनेजमेंट की प्रॉब्लम आ रही है। वी आर ऑल
इसको कंक्लूड जो क्रिटिकल फीडबैक है जो क्रिटिकल फीडबैक है वो बहुत अच्छा है, आपको सुनना चाहिए और उसके ऊपर अमल करना चाहिए। सो मेरा ख्याल है कि काफी चीजें फायदा होती है और आपने जो बातें की है और हमने स्टार्ट ले लिया और इसको लेके आगे चलेंगे इंशाल्लाह।
और मैं बात तक महदूद नहीं रहूंगा। आप जो काम लेके टास्क देंगे
जी विजन ही ये है, देखिए पीईसी भी है, पाकिस्तान इंजीनियरिंग कांग्रेस भी है, इंस्टीट्यूट ऑफ इंजीनियरिंग आईईपी इज द जो सबसे पहले से अपनी हिस्ट्री लेके चल रहा है एंड दिस इज द नॉलेज सेंटर फॉर इंजीनियर्स। तो इसको इंशाल्लाह इसी तरह डिवाइड करने लगे इसी विजन से
पहले यूनिवर्सिटीज में जितनी भी रिसर्च होती थी वो लाइब्रेरी की लेकिन अभी पिछले जुमे गैरिसन यूनिवर्सिटी में मीटिंग हुई है, इसमें हायर एजुकेशन के जो फंड्स हैं उनसे जो ये है कि जो रिसर्च हो, मैं भी उस कमेटी का मेंबर हूँ, तो जो रिसर्च हो वो आगे कमर्शलाइज हो। तो ये चीजें तो वहाँ मैंने यहाँ पे विजिट किया था इंस्टीट्यूशन ऑफ इंजीनियर्स में, तो कैनरा इनोवेशन सेंटर इसमें है, तो हम इकट्ठे मिलकर सारा जो है वो इस पे काम करें।
जी इंजीनियरिंग बेस्ड इंक्यूबेशन सेंटर यही है। इस वक्त नेशनल एनआईसी बन चुका, प्लान 9 पीआईटीवी का बना हुआ है। मैं बता रही हूँ सॉफ्टवेयर इंडस्ट्री की एक एप्लीकेशन की ई-कॉमर्स करके उसको लॉन्च कर रहे हैं। हमारी इंजीनियरिंग कम्युनिटी अभी उनके साथ इंटीग्रेटेड नहीं है, वो यहाँ से इंशाल्लाह होनी है और हम लोग आप और मैं हम इंडस्ट्री से आके यहाँ पे अपना वो नॉलेज दे रहे हैं जो कि उधर एकेडमिया में चाहिए। तो यू आर देयर, आपकी रिसर्च जो है वो चीज कमर्शियलाइज जहाँ पे इंडस्ट्री एक्सपर्ट्स मिलके करेंगे। सो प्रैक्टिकली इंशाल्लाह प्लान्स बहुत हैं और जून से इसको एग्रेसिव लॉन्च कर लेके आते हैं। और जो आपकी बातें बहुत ज्यादा बिकॉज आई थिंक मैं जहाँ पे बड़ी चीजें कोशिश कर रही हूँ लेके चलेंगे इंशाल्लाह सब तो जरूर।
इंक्लूजन की तरफ भी बहुत काम है, फीमेल पार्टिसिपेंट्स भी हैं। आप लोग कुछ कहना चाहेंगे तो आई वुड लाइक टू हैव योर कमेंट्स। आप कुछ कहना चाहेंगे? नेक्स्ट टाइम लाइक हमारे फीमेल इंजीनियर्स हैं या फीमेल पार्टिसिपेंट्स हैं जो भी हमारे हैं, अपना पॉइंट ऑफ व्यू भी बताएं। आपको नहीं लगता कि यहाँ पे इतने सारे लोग मैं उनको अच्छा लगता
है। मैं जी अपने कोई कमेंट्स दे सकता हूँ? मेरी आवाज आ रही है?
आपकी आवाज सिस्टम से डिस्प्ले हो रही है, उनकी आवाज आपकी
मैं चाह रही हूँ कि हमारे कोई ऑनलाइन पार्टिसिपेंट कुछ कहना चाह रहे थे। अगर हमें उनका क्वेश्चन चैट विंडो में मिल जाए तो हम उस पर रिप्लाई दे देंगे। अच्छा, ये तो पहले तो पीसी नंबर्स आए हुए सबके। 99 पार्टिसिपेंट्स ने हमें आज ज्वाइन किया हुआ था। ये चैट विंडोज मुझे बड़ी नजर आ जाए, इसमें बहुत सारे क्वेश्चंस भी हैं, देख सकते हैं हम, है ना? एक एक खुल रहा है बस। ठीक है, कौन है जी? वो उन्होंने हमें, इनको अनम्यूट कीजिएगा। गुलाम अब्बास साहब हैं जी। गुलाम अब्बास साहब, आपको पता चल रहा है? आप प्लीज अपना क्वेश्चन कहें। मेरा ख्याल है उन्होंने वैसे जी। गुलाम अब्बास साहब, डू यू हैव एनी क्वेश्चन? आपने कुछ पूछना? ठीक है, कोई नहीं फिर with thanks to all the participants online, अब हम इस मीटिंग को कंक्लूड करते हैं। इसकी रिकॉर्डिंग या इसके हवाले से जो आपके लिए डॉक्यूमेंट्स हैं वो इंशाल्लाह आपको यूट्यूब पे लिंक आपको शेयर कर दिया है, उसमें अवेलेबल होंगे। साथ इसमें आज के लेक्चर के जो हमारे अटैचमेंट्स थी। चलें, थैंक यू सो मच जी, जज़ाकल्लाह। Stay connected for more and you'll be getting our calendar and keep joining us.